All right, so this is going through vectors. Okay, this one will be the last day we talk about vectors. I think we have to move on already. Huh? Yeah, so for vectors, this one homework 5. I see most of the questions are correct. So I'm just going to zoom in on those that you got that I'm finding a bit funny. Can I know this one 3A? Where do you get this formula from?
Like my school summary book.
Oh, okay, can. So yeah, correct. It works.
Oh, okay.
Yeah, can. But usually I will do this. It's the same. This capital D here is the right hand side vector. Wait, no. This is a direction vector, I believe. If I'm not mistaken. But typically I will just follow this version of the formula and I will draw a picture. Okay. When you're trying to find the perpendicular distance from a point to a plane. Alternative is to find the find the foot first, and then you find the vector PF, and then you find the magnitude of the vector PF. Okay.
Okay.
Yeah. I'll just move on. You can read the corrections later. No, part B. This one cannot. What question are we at? Question 3. Let me take a look. Question 3. Oh, you'll find the right question first. Yes. Question 3 part B. What was the question asking? Find the perpendicular distance of the point 13 negative 1 from the plane. Okay, first thing is I don't like this notation. Whenever you got a point, you should label it from side to side. Okay, from left to right, sorry. 13 negative 1. Because here you're describing a position vector. You're describing vector OP, 13 negative 1. And you didn't even draw the arrow, so writing down the position vector is not that accurate. Okay? Write it from left to right like this. Find perpendicular distance of 13 negative 1 to the from the plane. What is wrong with this? You let Q be 13 negative 1 when they already when you already labeled the 13 negative 1 beside a point P. Right? And a point Q, it should be a 030. Oh.
Yeah.
Then that's why the working is not correct. I think you got mixed up. This should be yes, you should say let Q be the 030. I think
then
so.
I get correct already.
Sorry?
If I like put the correct Q, then it's correct already.
Not yet, because you need to do a dot product. Because what you're going for, I believe, is this strategy here.
Yeah.
Where you find the vector dot product with the normal. So here you still need to do dot product with the normal and then take the modulus. You didn't take the modulus.
Oh, yeah.
So yeah, no, not incomplete. Maybe I'll just go through this. What I'll do is I usually draw a vector in 3D space like this. There's a point P, and then it has a line that cuts through here, and then it goes down and continues. Okay. What is the question? Let me read again. You have a normal vector here. What is it? It's 3, 1, negative 2. And then you have a 0.13 negative 1. That's a point P. And then what you did is you found this point Q, another point on the plane. You found out it is 030. Okay, then the goal here is to find out the perpendicular distance here, which is distance from the point to the plane. There's a foot here, F, but here a bit long-winded. If you try to find the foot, you can, but don't need to. You can just use the dot product formula. Then how do we do that? We take QP, dot product with vector n, modulus on top, divide by length of the vector n. This QP is like the Michael Jackson. the normal, maybe I should write it over here, it's like the floor. So if you want to find the length of projection of Michael Jackson and the floor, it will just be the purple line. Okay, this is just length of projection formula. Okay.
Okay.
Yeah. Then I'll leave you to fill in the rest. Is that okay?
Yeah.
You know how to do this, huh? Yeah. So what you did is you can find the y which is incomplete. Still haven't answered the question. Okay, next. For part 1, notation, line should have a vector r equals. Correct. Okay, what's wrong? Maybe it's better if you can say let x be the point of intersection between the line and the plane. Here. And then later on, you can just describe vector ox equals. It makes it a bit neater. Okay, then use sine theta because it's angle between line and plane. Okay, that's good. Part 3, also okay. You're just using an application. You realize there's a right angle triangle, so you can make use of sine theta. Correct. What's wrong? Here. Just note that for question, what is this? Question 5, the last part. If you look at the answer key, the equation is a bit different. But that is okay, I believe, because the equation of a plane is non-unique. Okay, you just didn't divide by 5, but it's also correct. Answer key gave x minus y equal -1. Both are okay.
Exam, should I divide it?
Simplify, yes. Simplify as much as you can.
Okay.
Okay, good. Yeah. Question 5. Next one. The careless mistake. This one should be a minus. Yeah. Yeah. I believe you copied the question wrongly or something. Question 6, part 2. Let's see. This is question 6, part 2. Let me scroll down to the question. Yeah, you copied the question wrongly. It showed z minus 3 over k, but you write down z plus 3 over k.
No.
Yeah. I just be careful about that. So over here should be plus 3. Okay, anything else? Then just area carry forward all the way. Your working is fine. You just somehow, I don't know what happened, but you auto correct yourself from -3 into a +3. Not sure what's going on. Were you looking at answer key? I don't know. Okay, but let me know if you don't understand. If not, most of your working is perfectly fine. It's just that this -3 here, careless mistake, it should be a +3. Then if you want to find point of intersection, just equate each of the components. Then after that, you solve for lambda and mu. Then you sub back in, and then you solve for k. Sub back in into the third equation. Oh, then you solve for k. Correct. Yes. Okay. Moving on. Here, what is wrong with this? Error carry forward again. Should be a +3 here. Then -7 mu. Then I don't know what happened, but somehow you managed to get a +6 here. Right? You wrote down -3, and then there's a ×2. -3 is wrong. Then I would expect that you would multiply, you get -6, but somehow you auto correct yourself into a +6. Not sure what's going on. Okay, but this is correct. Do you have any questions?
Nope.
No. Okay, then you solve for mu.
My head
Yes.
are working. Oops.
Sorry. Can say again?
I think I changed it in my head, but I never changed to my working.
Oh, okay. Yeah, just be careful. Be consistent. Okay, but you get what's going on, then that's good. So solving for mu, you get 1. Sub in back into the equation at the top. This one, sub in. Then you will get your vector, what is it? The coordinates of the point of intersection, is it? Yeah, point of intersection between L2 and the plane P. Okay, moving on. What do we have? Part 4 is fine. Angle. Question 7. Oh, part 1, okay. Part 2. Okay. Then part 3. Okay, part 3, you had a problem with it. Okay. The goal is to find an expression for the distance from point A to plane P1 and from point A to plane P2. Yeah. So does this diagram help? It's a laptop here, which is essentially two planes.
Ah,
And this is a earpiece holder, whatever. It's just a point in space. So I represent it by point A. And then you have two lines, the orange lines. Do you see that they are perpendicular to the planes?
oh, yeah.
Then these two distances are equal. That's what the question is saying when they say equidistant from the plane.
Oh,
Clearer? Yeah.
Yep.
That's question interpretation. So point A is equidistant from the plane. So this is the diagram you should have. Now to draw it nicely, here's the diagram I have. You have a plane P1, point B is on P1. You have a plane P2, like this, 3D space, it intersects along here, a line. Then you have another point, oops, sorry, let me get rid of this. You have a point D that lies on plane P2. Then they want you to, they are telling you that the perpendicular distance from this point A, 43C1, from the first P1 and the second plane P2, they are equal distance, which is really just a normal vector. Vector N1 and vector N2, they are equal distance, the yellow color highlight. Then, but what else? There is also, they are saying that the two possible values of C means that there are two possible coordinates of point A, right? Can be 43C version 1 or 43C version 2. So I label as A and A prime. In this case, you can actually just ignore this A prime. Just have a generic C can already. Okay. And then the algebra will help you to solve for C. You'll get a plus minus when you try to solve for C. Okay. Then how do we do it? What we can do is to realize that, actually, to find this yellow color line, there's a torchlight over here on top of the blue color vector. So it's really just the length of projection, right? Of the vector AB onto the normal. Likewise, to find the vector M2, it's just the length of projection of vector AD, the torchlight over here, onto the floor vector on the normal of plane P2, which will give us the perpendicular distance from point A to the plane P2. So from these two scenarios, we can write down two different equations for the length of projection, right? The first picture, we get one equation involving length of projection. The second scenario, we also get another equation involving length of projection. Then you can express those two expressions in terms of what is it? Let me look at the solution. I kind of forgot what's going on. Yes, then from there you can get two different expressions for the length of this line, the length of this line segment. And we know that they are equidistant, so we can equate the two lengths, and then we can solve for C. Okay. Okay. That's what the solution gives up. Maybe I'll just share the solution key so I can save some time. Here. Okay, this is part 3. You can see equation of P1 is R dot 2 negative 2 1 equals to 1. Yes. Then 111 satisfies the equation of P1, so you can let position vector of one of the points on P1 be vector OB111. Okay, that's exactly what you found as well. The point B. Let me think a little bit. Okay, wait. I think it's better if I do it on my iPad. Hold on a second. This is question 6 or 7.
7.
Oh, 7 already. Okay. Let me scroll to the right page. Yeah. So maybe I'll just split the screen. Yeah. Okay, so here's the diagram on the left. And we can just look at the solution while we look at the diagram. Okay, yes. So what was I saying? This part 3 here, yeah, we got the equation of the plane, and then we find out that there's a point B, which is represented, which has a corresponding position vector 1, 1, 1. Which I have labeled over here, point B. Then the distance of the point A to the plane P1 means that I'm trying to find this first one, the length of this first yellow color portion, using the length of projection formula. I'll just take vector AB, okay, dot product with the normal of the plane P1 divide by the length of the plane P1. Okay, this is length of projection formula. Okay, simplifying, you eventually get to 1/3 C modulus C plus 1. Can I just skip the intermediate working?
Yeah.
I skip first. I think you all know how to simplify. Okay, then 1/3 C plus 1 modulus. Must have the modulus. Don't drop the modulus. Later on, you now have a P2. That's the equation. You also find out that there is a point D, coordinates 0, -1, 1, which I've labeled over here. And of course represented by a position vector OD. Then same thing, you just take the vector AD, vector AD here. Can you see the highlight? AD, then you take, which is represented by this AD over here. You take the dot product with its normal vector of P2. This guy here, -632. Then divide by the length of the normal. Blah, 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 intermediate working, and then you get 2/7 times modulus of 7 minus C. This part, okay? So now you got two different expressions, 1/3 modulus C plus 1, 2/7 modulus 7 minus C. Those are the two different expressions for the distance from the point A to P1 and distance from point A to P2. Then you can just equate them together because equidistant. Okay? And that's exactly what they did here. They just say given, and therefore they are equal. Okay, then you can just solve. This one, what's going on is that when you have modulus on both sides, you can just open up both of them. Okay, so from here, modulus turn into brackets. Here, the modulus also turn into brackets, but you just need to introduce one plus minus. Okay, when you open up the modulus, must introduce a plus minus. Is that okay? Yeah, that's how you get the two different C values and hence two different things.
Why is it on one side only?
Because what does it mean when you have modulus? Modulus means you are converting negative numbers into positive, 0 into 0, positive into positive. So what does that mean? It means that if you work backwards, you'll end up with what? You end up with two possibilities, either negative or positive. Of course, if you write down plus minus, that will cover all the cases, but with an extra 0. So what this means is that if you work it out, the left-hand side will become normal bracket, but you have plus minus. The right-hand side will be 2/7, same thing, convert into normal brackets, but you have plus minus. Here, when we say plus minus, what we are doing is writing a shortcut. We're considering two cases. It could be a positive or it could be a negative. Of course, it will be 0 if C is -1, but let's not consider that case. And then the other one will be positive and negative. So this is a test of your permutation and combination skills already. There are how many ways? 2 ways here. How many ways on the other side? Also 2 ways. So what's the total number of ways? 2 times 2, 4 ways. Plus, 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 minus, minus, plus, minus, minus. Oops, minus, minus. So if I write it out explicitly, what would it be? It would be the equation. What this means is if it's plus plus means I get 1/3 C plus 1 positive in front, 1 and 2/7 minus C positive. The other case will be plus minus. So positive and then there's an extra negative sign on the right side, -2/7. Third case will be the negative sign on the left, but positive on the right, something like this. Last case will be both are negative. What do you notice? What do you notice? There's a repetition. Do you know that? Do you notice that these two equations are essentially the same?
Yeah.
Right? Just times -1 on both sides. So they are equivalent. And these two are the same.
Why?
You just have to multiply -1 on both sides.
Oh, okay.
I tell you A equals to -B, so it's -A equals to B. Right? This is like my A, that's my B, with a minus in front. This is my minus, that's my A, that's my B.
Mm.
So they are the same.
Okay.
Is that okay?
Yeah.
Right? So since these two are the same, you only need to list out the unique ones, which means that all you need to do is to focus on the first two.
Mm.
That's positive, positive, that's positive, that's negative. What's a simpler way to write it? Combine them together, plus and minus combined together.
Mm.
Exactly what the answer key gave you.
Oh, okay.
So a bit complicated if you have to go through the logic every single time. So what you should do is to memorize. You got modulus on both sides. Oops, sorry. Modulus on both sides. You just open up both of them into normal bracket, but you only need to put down one pair of plus minus. Why only one pair? Why don't want both? I already explained. Okay, just memorize that it should be only one. Oh, because you only need two. There are only two unique cases. Okay, so moving on, then you can plus minus means what? Means it's just a lazy way of saying there are two cases. So what it means is 1/3 bracket C plus 1 equals to the positive version, or 1/3 C plus 1, I have no space, equals to the -2/7 times 7 minus C. Then you can just distribute. So here what they did is okay, I'll just expand it. So times 21 on both sides. So 21/3 gives me 7 times C plus 1, I get 7C plus 7. Then on the right side, I also times 21. Maybe I should write this down now. Let me get rid of that. Then what do I get? 21/7 is 3. 3 times 2 is 6. 6 times 7, 42. 6 times minus C is minus 6C. Is that okay?
Can.
Can now? Then that's how you get the first equation. Then you do something similar with the other side. If I can get my highlighter to work first. Hold on a second. Sorry, give me a moment to restart my app. Resume share. Can you see my screen?
Yeah, can.
Okay, this one. So yeah, we get the first equation. Likewise, you can do something similar and simplify it to the other guy. 7C plus 7 equals to -42 plus 6C. So you just solve for C in both cases, you get 35/13 or -49. Can?
Can.
Okay, good. So of course, they tell you that the alternative is to draw the graph. You drew the blue color one, I believe it's 1/3 C plus 1. 1/3 C plus, highlight in yellow. It's the blue color one. I highlight in yellow. Then the other guy, the 277 minus C, that's the graph of the red color one. Y equal 2/7 modulus 7 minus X. On a GC, you must type X. Then you just find a solution for the point of intersection. So I believe there's one here and one here. That's how and it's -49 and 2.69. Okay, then that's your answers. 2.69 being 35/13. Yeah. Okay, Ken. That's it. Moving on. Next one. Part 3 done. Yes, about your question in part 1, you use a -5, 10, 5. It's slightly different from the answer key, but it's perfectly fine because you can always use when you're trying to find the equation of a plane here, like you take r dot with -5, 10, 5. The normal vector here, we only care about the direction, the length doesn't matter. So you can, the answer key, they use a different version. They use 301. Oh, so it's also okay. Yeah, they essentially realize that they are parallel vectors. So their direction is still the same. So that's why it's a bit different in case you are worried about it. Yeah, your equation is fine. Okay. Equation of a plane is non-unique. Non-unique because you can have multiple different direction vectors or normal vectors. Yeah, this one. Sorry.
Also. Why is it better to like simplify also?
yes, your future calculations will involve smaller numbers. Then it will make your life easier. Yeah.
Okay.
And this one is 2 1. What went wrong? I don't know why I circle. Looks fine to me. I forgot what I was doing. Right. Okay. Transfer error. This one, you got the correct answer at first, and then suddenly when you bring it down, you bring in an extra negative sign. Can you see? Half become negative half.
Oh.
I
No.
don't know what's going on. So blah blah. Just make sure you don't write the extra negative sign when it shouldn't be there. Yeah, an error carry forward. The rest is fine, I think. Oh, just note here your plus 50 should be the square bracket should be, you should close the square bracket and then the plus 50 should be outside. But your final answer is okay. I think so. What else? Okay, yeah, working is fine for question 8. Okay, moving on to question 9. Yeah, just error carry forward. Question 9. Question 9, nothing wrong with part 1 and 2. Okay, it's fine. Undo part 3. Part 4 also okay. Just draw a picture. Try to draw a picture or reflection. 10A, 10B. Oh, you managed to find out that the point C is the origin and the origin lies on the plate. You found that separate point. Then you did vectors TP, you find the length of projection onto the normal in order to find the length Pn. Right? Okay, good. Can. So you use PC is also fine. The direction doesn't matter. Okay. Yeah, PC doesn't matter because you're finding direction at the end of the day. Here you should simplify. 21 over 14, simplest form, 3 over 2. Simplest form. Okay. Rest is fine. Part C, circle, what happened? Let me see. What is this question first? Question 10, part C. Deduce or find otherwise the perpendicular distance from the plane P to the line of intersection of pi 1 and pi 2. Okay, I drew a picture for you here. Can understand?
Yeah.
If I just quickly redraw this, so there is my pi 2, and on the floor is my pi 1. Then there is a line of intersection here. Then what happens is that the angle here is what? Angle here we found out just now is 60 degrees. Maybe I'll just remove this in case it gets too messy. Then what we notice is that there is this perpendicular of the P2, this guy. And if you just continue extending this perpendicular down all the way until it collides with the P1 over here, that's my point P. Okay, and then you can drop a line down until you hit the line of intersection, and then you draw another horizontal line like this. What triangle do you see here?
Right angle triangle.
Right angled triangle. And what is this angle over here?
It's also 60.
It's still the angle between the two planes, so it's still 60 degrees. So now we have this most important triangle. We just extract it out. It's this fellow here, 90 degrees, 60 degrees, and a point P, and I can't remember all the other points already. But basically, in part B, we have already found out this length here. Oh, this part here is part B. It's the it's basically the perpendicular distance from the point P to pi 2. Then we also have a 60 degrees. Can we find the final part here? The distance here, the hypotenuse. How? What ratio do we use?
The cosine, a sine.
Sine, definitely, because here is 60 degrees, opposite is your part B length. Okay, so you're going to use sine. So sine 60 degrees will be equals to your part B's answer. I cannot remember what it is. I'll just write down part B. divide by the part C's answer, okay, which is our answer. Since we're at part C, I'll just write down answer, ANS. Then just make ANS the subject. ANS equals to part B's answer divided by sine of 60 degrees. Sine 60, I believe, is √3/2. Then you just simplify. Okay? Yeah, this is the deduce part. Really, you must draw a picture. If not, you will not be able to see the right angle triangle. Okay?
Okay.
My go-to drawing for intersection of two planes is 3D drawing like this. Okay, like a laptop screen. Like a laptop. But I make sure the base is longer because I need to draw more things. Okay, practice. You never practice, you can't draw it fast. Okay, yeah, I'll just move on from this. Part 3. What happened? Nothing wrong. Fine. Here, you read it, the question 12. Okay, I think, or maybe this is what you copied during the lesson.
Yeah. No. This one I redo.
You do. Okay, one thing to take note here, velocity equals displacement over time. Technically not correct. You must remember from AMAX, we learned already. SVA, displacement, velocity, and acceleration. Velocity is not displacement divide by time. It's integrate. Correct. Or differentiate. As you differentiate, then you get your V. Displacement differentiate, then you get your velocity. Then velocity, you have to integrate to get back to your displacement. You don't just divide by time. That's only for scalars. Only speed is equal to distance divided by time. Okay? This is okay. This one, maybe you never take physics. I also didn't take physics, but I still know this. You should know this. Velocity is a vector, then speed is a scalar. You cannot just compare. You cannot. They cannot be just a division relationship. Okay. Yeah. So what did I want to say? Okay, I just redraw the diagram over here. I realized that you didn't draw for me the two different vertical buildings. Okay, two different buildings. Right, in your diagram. Your vector OB. Vector OB. What is point B? It's point B. -500, 25000. You put it ambiguously in the middle. Not sure what you're referring to. What is this? You see? You don't understand your own drawing.
Yeah. It's supposed to be the two things. Yeah, it's NB is the navigation beacon.
NB is the navigation.
Control
Press
tower.
N. CT is. Oh wait, there's an N. I thought it's an O.
Yeah, I also thought it's until I look properly.
Okay. All right. Okay. Navigation beacon and control tower. Yes, correct. Okay. That's beginning to make more sense. That's an N, right? Okay. -500, 2500, and 0. You should not write it as a vector. Okay. Try to write it as a coordinates point. So -500, 2500, 0. Also, it will be better if you expand your diagram to beyond just 5 lines. You might need more space. You definitely need more space for this diagram. Here I have an iPad, so I can zoom in and write in the details. But typically, I would take up maybe half a page. If I was actually writing in a real foolscap paper, I would draw a super big diagram. Okay? Please draw bigger. Also, you try to squeeze the vector like this. Very, very confusing, very messy. You see, white space is important. You must have white space in between your working. So, like in my drawing here, what I have is I highlighted everything in color already. Light blue, maybe my explanation during lesson was not so good. So I tried to improve the drawing here. Over here is the control tower. And then at the base, the yellow color here is the base of the control tower. That is your origin. Okay, how do you know it's the origin? Because if you read the question, they said 10 seconds later, the plane, passes over a navigation beacon with position vector -500i plus 2500j relative to the base of the control tower. When they say relative to the base, they are telling you this fella is the origin. Base of the control tower is the origin. Yeah. Okay, then the other tower will be, the other building here would be your navigation beacon. And as also a corresponding base, the green color one. In this case, they already told you it's negative 500 I plus 2500 J, right? So that's why it's negative 500, 2500, 0. However, this, what do you call this? Navigation beacon, they told you it has a height of 200. So you have to add on 200 to your Z component. So you get the top here, negative 500, 2500, 200. Okay?
So as long as I see like relative to the base, then the Z is 0.
The relative to the base of the control tower, then the base of the control tower will be
0. Okay.
Yes, correct. Yeah. Okay. But so really must draw the picture. Then you can understand. The height of this control tower, irrelevant. They never mention, it's also irrelevant. Because what happens is that the plane, they tell you it passes through it passes through this point. Okay, it doesn't actually hit it. It just pretend that it doesn't hit it. Okay, it reaches this point, negative 500, 2500, 200. At point t equal to 0, they told you that it is some, they didn't tell you what is the coordinates. You're supposed to find this out on your own. Negative 800, 2900, 240. Then you, after 10 seconds, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, eventually you reach this point here, negative 500, 2500, 200. And within these 10 seconds, it travels at a constant velocity of this fellow here, 30, negative 40, negative 4. What you need to understand from this is it's not velocity equals displacement over time. That's actually not correct. Or integration. No, this is totally not a differentiation integration question. What you need to understand is that this is really just the direction vector of the line, the blue color line. The blue color line being the path taken by the aeroplane. Do you understand what I mean by path taken by the aeroplane?
Yeah.
Can I start here?
Yeah.
So I draw for you an analogy. If you know what's a red lion during National Day parade, parachute drop down.
Yeah.
They have a gas canister, then they'll release the gas as they move down. Also, they'll go down. So if you look at the gas that is produced, that's tracing out the path that they took. That's what we actually call the locus. The locus of the red lion, of the path taken by the red lion. Here, locus has been removed from your syllables, so it's been moved to further math, so you don't really need to know. But you implicitly need to know it from here. It's quite easy, right? It's just a path taken by a whatever object, in this case, the aeroplane.
Yeah.
Then what you need to do now is to figure out how do you get this t minus 10 here? How do you get this t minus 10 here? Maybe another way that I can explain this is the following. You must know at the end of the day, it must look something like this. This guy here, minus 800, 2900, 240 is the position of the plane at t equals to 0. Then you must increase your t value, t equal to 1, t equal to 2, until t equals to 10. And it has to move in a certain direction. So what this means is, we at first don't know what is this. So we can call it ABC. Then you can add on t times of the direction vector. That's this part, t times the direction vector, is obvious. Then now you can just work backwards. Let's see. You start off with unknown A, B, C, and then you add on the direction vector 30 here. So you put 30 times some number. In this case, if you can vary the number from 111 or 222 or 333, but eventually you reach 10, 10, 10, right? After 10 seconds. So you add on 30 times 10, you add on the second component, negative 40 times 10, and then you add on the third component, negative 4 times 10. Eventually, after this 10 seconds traveling in the traveling in the I direction with a magnitude of 30, you will eventually reach the point negative 500 in the X component. Then from here, you can solve for A. Does that make sense?
Yeah.
It will be A equals 800. Okay, likewise for your B, likewise for your C. And then you will be able to get your A, B, C being minus 800, comma 2900, comma 240. Okay, that's another way to work it out. This T minus 10 one is a bit more sophisticated. You're basically working backwards. You start with the point here and then you try to work backwards. So instead of 10 minus T, it will be a T minus 10 in this direction. You're basically considering it, what if T is equal to 1? Then this will become negative 9. Negative 9 of this guy. What does negative 9 of this guy mean? It means that you take negative 9 steps in the direction of this guy. Negative means you have to go in the opposite direction, but you take 9 steps. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Until here. Somewhere here. Then if you have T equals to 2, means T minus 10 will be negative 8. So you take 8 steps instead. Up to here. And then so on and so forth until you eventually reach to T equal to 10. 10 minus 10 is 0. 0 steps of this means you eventually reach this point.
Oh.
Does that make sense? So there's only one possibility for you to have taken 10 steps for you to reach back to this original starting point. Or not really the original starting point. It's more like the ending point, but we are working backwards. So that's why we have a T minus 10 here.
So the T minus 10 is referring to the T equals to 0?
It's just substituting the lambda here. What do you mean by sub T equal to 0?
Like you said, the T minus 10 is move backwards in like move backwards.
It's moving backwards because this T minus 10 is just an expression to consider what happens when T equals to 1, T equals to 1.1, 1.2, 1.3, all the way to 2, then 3, then 4, all the way to 9 to 10. Then after you sub in a particular value of T, you'll get a negative number. Like for example, if T equals to 1, then you have a negative 9, right? If T equals to 1.
Yeah.
What happens when you have negative 9 in front of 30, negative 40, negative 4? How do you interpret that?
Becomes positive.
No, negative 9 multiplied by this direction vector.
Like the negative 40 and negative 4.
Yes. Okay. No. Okay, you don't get. I think what I want you to understand is when you got negative 9 multiplied by a direction vector, this direction vector here means this arrow here. Correct or not? But you have a negative 9 in front. So how do you translate this into a picture?
Like
what's negative 9 times?
It moves like backwards by like 9 arrows.
Yes, exactly. 9 arrows. My arrow is a bit too long. So 9 arrows later, it will end up somewhere here. Does it make sense? Okay.
Yeah.
So what we do is if we work through this logic, when T equal to 1, you go backwards by 9 arrows. T equal to 2, T equal to 3, go backwards by a certain number of arrows. But when T equals to 10, you go backwards by T minus 10 arrows. 10 minus 10 arrows, which is 0 arrows. Then you must end back up at this point here. So that's why this equation must be correct. Can?
Wow, okay. Can.
All right. If that is confusing, I think this other explanation is a bit simpler.
Yeah.
Okay, that's part A. The rest, I think I don't go through the question already because I already went through it last lesson.
Yeah.
Okay, then section 2. Okay, this one just work on your English phrasing a bit. This one must draw a picture to find the coordinates of B. Yeah, you didn't find the coordinates of B. You found the foot already. You found the point A. Then you can find the vector OB already. But you didn't try to find it. What would you have to do? Duck feet. Use what?
Use the ratio theorem.
Yes, ratio theorem. So I'm not gonna go through this. I think you know how to do this. Go and read the solution. Okay, vector OF equals to OA plus OB divided by 2. Then you just make OB the subject. Okay, vector OB. Okay, and then this one you draw question mark because you haven't find the vector OB. Never answer the question for part 3. So once you got that, you can just sub in and you get the answer. Period of triangle. Okay, question 2. Okay. Must put a dot there. Some questions will directly ask you for the exact answer. Right. You gave a rounded off answer here. But you should try to leave your answer in exact form as much as you can. But if you have no time during exam, just leave as 3SF, it's fine. Okay, this answer is correct. Okay, then part 3, what went wrong? Oh, part 4 we can ignore. Sorry. This involves three planes, which is no longer in our syllabus. So skip that. Part 3, what you need to understand is the picture. Must draw the picture. Okay. This is question 2, part 3, right?
Yeah.
Okay, 2 part 3, they tell you L is the line of intersection of the planes P2 and P3 with the equation blah and blah. So I draw for you a P2, I draw for you a P3, a laptop, and then there's a line of intersection, a purple line here. That is your L. What do you want to do with this information? You want to find out what is B and C. Okay, the trick here is to realize that the normal vectors of these two planes are, if you cross them, what happens? You'll get a vector, this purple guy. And what do you notice about the direction of this purple resulting cross product and the line?
It's parallel.
Parallel to each other. If it's parallel, then you can form an equation already, right? N2 cross with N3 is equal to K times of this -1, 0. Then from here, you can set up 3 equations and solve for the unknowns. Solve for K, B, and C. Can? Yeah, you go and read the solution. They showed you how to do it. Okay, then 3 part 1. Why is it circled? What happened? Answer the question. You never answer the question. Very bad. You solve, you get this perfect, but you never answer the question. You don't get the mark. What is the question asking? Let's see. 3 part 1 is asking you to show. Show is given by this equation. Correct. Show that the vector equation of the plane P1 containing A, B, and C is given by R dot with I minus 2J plus K equals to 0, which is 1 minus 2, 1 vector. Here you gave me 3, -6, 3. You haven't answered the question. How do you link it to 1, -2, 1?
Must factorize out the 3.
Yes, exactly, over here. Since 3, -6, 3 equals to 3 times of 1, -2, 1, that means that 1, -2, 1 is a parallel vector to this 3, -6, 3. And then this one you don't have to say. You just need to conclude that therefore a normal can be 1, -2, 1. And therefore you can get this updated equation.
Oh, I see.
It can be any parallel vector. The length doesn't matter. Here it's just using a normal vector that is 1/3 the length of 3, -6, 3. Okay, your equation is fine, but you must answer the question. Must convert it back to what they want. 1, -2, 1. Okay. Can. Good. Next one, part 2. Wrong ratio. Ayo. This one, when they tell you 2 times of CR equals to CQ. Is it 2 here or is it 1? It should be a 1. Can you tell why? CR to CQ, 1 is to 2. So what's the remaining here?
It's 1.
It's 1, right? 2 minus 1 is 1. Here you wrote down a 2, so that's why it's wrong. Error carried forward, a whole question wrong already.
Okay.
Okay, but your working is correct. I'm not sure how strict they are in A levels. Will they give you method mark or not? But basically, your method is correct, but error carried forward all the way.
Okay.
Yeah. Okay. Oh, wait. There's something wrong. Not just the concept. One thing, I think it's a careless mistake over here. When you want to find the position vector of R being the point of intersection between L1 and L2. You're supposed to use you write down dot product equal to 0. Can you tell me what does it mean when you have dot product equals 0?
That means it's perpendicular.
These two vectors are perpendicular. So let's take a look. What is this first vector here?
There's OR.
Vector OR. What's this 2, 1, 0 here?
The L1, the direction vector L1. So it's V.
Are they perpendicular?
No.
No. OR is somewhere, like let's say point O is somewhere here in the middle of nowhere. Then that's OR. Then where's my AB, which is a direction vector? It's this guy here. Are they perpendicular? Not
No.
perpendicular. So what do you need to do to find the perpendicular vector? This vector here, OR, must be modified a bit. You actually should be finding out vector CR. CR over here, can see or not?
Oh, yeah.
CR is perpendicular to AB. So you still need to do one more step. Find vector CR first. OR minus OC. Okay, you missed out on that step. Then you take the dot product. All the rest of the method is fine.
Okay.
But this one, please take note. Perpendicular vector. So always look back at your diagram. Over here, I think you have a misconception. You say that as R lies on L1, then you write down capital R dot dot, and then you write down the vector. That's not very accurate. You should be writing down an actual vector already with an arrowhead. This is equal to something, then an arrow on top. You need to figure out what those 2 points are. Okay, you don't just write down an R dot dot. Do you understand? Don't just write down R dot dot. Okay, it's wrong. This is literally a vector. It's a position vector.
Okay.
So it's vector OR. It lies on the line L. Point R lies on the line L. L1. And there's a point R. So what we are doing is we are finding out our position vector. Every point on our line can be represented by has an associated position vector. Okay. So yeah, it's always OR. O something. Okay, moving on. Part 3, what went wrong? Here just have to be a bit creative. Part 3 is asking you to find the exact area of the triangle BCQ. BCQ is over here, right? The blue color triangle, you see?
Yeah.
Then what is the area of this triangle? Is half times base times height, where the base is QC and the height is BR. Agree?
Yeah.
Very good. But what is half times of QC? It's actually just CR, right?
Yes.
Because there's a 1-to-1 ratio, not 2-to-1, 1-to-1. Yes. Yes,
Yeah.
Then therefore it's just CR times BR, which is just the length of vector CR times the length of vector BR. You can find vector CR and BR already. N minus start. OR minus OC, OR minus OB. Can?
Oh, okay.
Yeah, then just fill in the blank and find the distance formula. Use the distance formula. Okay, so the key here is draw a picture. Look back at your diagram. It would be nicer if you can draw a bigger picture. Draw a bigger triangle. Maybe you'll see clearer. I don't know. Maybe. Okay. Part 4, what went wrong? It's fine. I just drew a nicer picture for you. You have 2 planes, right, that intersect. How come you only draw 1 plane? So funny, Right, the question talk about 2 planes, then it's perpendicular to pi 1. Or then you just draw 2 planes. Draw perpendicular. Test train your art skills a little bit. I think it will be useful. Okay, can go take a look at this diagram later. Moving on. Good. Question 4. Over here, yes, you did some kind of manipulation. The direction vector here, AM, you suddenly converted into 632 without any working. Wow, very good. Yes, you can do that because they are still parallel. Is that clear?
Yeah.
Can Okay, good. That's why you get this line AM. Then something wrong again over here. Whenever you take dot product of 2 vectors and you write down equals to 0, can you tell me again what's so special about these 2 vectors? You're assuming they are?
Yeah.
Exactly, perpendicular. What is 632 here? Direction vector of line AM.
AM.
AM. What is -6 plus 6 lambda minus 3 plus 3 lambda 2 lambda?
No, ON.
Vector ON. Where is vector ON? O is somewhere in the middle of nowhere. This is vector ON. Are they perpendicular?
No.
Pink color and purple color, not perpendicular?
No.
Very good. So that means you're wrong. This is wrong. So what are you supposed to find? Instead of vector ON, what should it be?
The BN.
BN. Yes, that's the key step you're missing. You need to find out the vector BN first. ON minus OB, then you get this updated guy. Then you dot product with the 632 equal to 0. Solve for lambda. Can? So you made the same mistake 2 times. So is it a misconception or is it a careless mistake?
I think careless.
Okay, so you are consistently careless. Okay, please be careful. You must always be perpendicular vector. Look back at your diagram. You literally wrote down ON. So it means that you write down ON, but you never look back at your diagram. Okay, ON, if you draw a picture, you will be super clear. Point O is here, point N is there. So this is my pink color vector ON. Obviously not perpendicular to the purple one. Then you know it's wrong. That's how you double check. Look back at the diagram.
Okay.
Okay, moving on. Draw a diagram. Say many times already. Look back at the diagram as well. Over here, your method is fine. You find the foot of the perpendicular. Just arrow carry forward. But then yeah, it will still work. I worked it out for you already. They didn't show you in the answer key, but I did it for you. Lambda equals 72/49. Sub back in, get vector Bn. And then after that, you use perpendicular distance formula. Square root a square plus b square plus c square. I draw my 3 happy face because I can't be bothered to copy down the fractions. And then eventually you get this 12 times square root 13/7. There are 2 other methods that are shown in the answer key that are shorter. I will not go through them. You can go and take a look. It basically involves the length of projection formula as well as involving the dot product and the perpendicular distance formula involving the cross product. Okay. Those workings are shorter instead of finding the foot. Yeah. Okay, moving on. Part 3, yeah, just find area of a, let's just find a cross product. Hold on, let me see what is this question asking about. This is question 4, is it? Question 4, part 3. Find the acute angle between line DV and the plane A and B. Yes, correct. You just need to find the direction vector of the line DV and the normal of plane A and B. I think this is the normal, right?
Yeah.
Yes. Okay. Can. Good. Something funny. You. Wait, no, nothing wrong. Okay, it's fine. Okay, moving on. This one, part 4. Sorry, please skip this question because it involves 3 planes. It's no longer in the syllabus. This question was from 2014, so it's no longer in your syllabus. Okay.
Okay.
Can. Good. Moving on. Over here, your 5A part 1, you have a vector 1, 1, 1. That's your vector OC, right? Like AC is OC minus OA.
Yeah.
Yes, Then what I'm saying here is that you should show some working. You should say let C be another point on the plane pi. Then you just double check. 1, 1, 1 dot with the, then you substitute this vector R with 1, 1, 1 in the equation of the plane. This guy here. And then you realize, it coincidentally equals to 3. Therefore, vector OC 1, 1, 1 is a point on the plane. Point C is a point on the plane. Okay, and vector OC is the associated position vector of the point C. So it's 1, 1, 1. Okay, then after that, yeah, your working for this is fine. So nothing to talk about. Next. Also, one more point here. Whenever you find the angle, right, you should round off to phi SF or something that's more accurate, any degree of accuracy. And then after that, you round off to the final answer. Reason being, this more accurate answer will need to be used later.
Oh, okay.
Okay. Yeah. Or alternative is to type in this exact form, sine inverse, to get the exact answer, exact angle. But usually I find it a bit troublesome, so I just use the phi SF version. Definitely not the 1DP version. That one, the accuracy too inaccurate already. Please use the one with more decimals. Okay, then for part 3, draw a picture. That is the advice. Here is the picture. What is it asking you to do? This is question. Okay, they are telling you. Let me think a bit. Oh, right. Okay, so let's read the question first. This one is question 5A part 3. Let Q be the point of intersection of L and pi 1. So I should label here L or pi 1. Without finding the coordinates of Q, deduce the length of AQ correct to 3 significant figures. So what we found out from part 1 and part 2 is that the perpendicular distance from A to pi 1, that's just this part here, right?
Yeah.
Can you see? And then from part 2, we know the acute angle between L and pi 1, 24.839 is this angle here. And you can also see a right angle triangle here. Yes? Then what is the question asking you to find? The length of AQ. Here. Then you can tell straight away. This one mark question means you just need to use Picasso. Which one?
The sine.
Exactly. Here is the angle opposite over hypotenuse. Then I think you know how to solve already. You can look at the answer key. Sine of 24.839 will be the part 1's answer divided by what you want in this. No. This should be part 3. Divide by what you want in part 3. Sorry, this should be part 3. Then you just make this hypotenuse the subject. Same thing as just now. Okay, moving on. B part 1. Okay, good, perfect. How about B part 2? Also almost there. You're almost there. You reach this step. This is very good. Okay, you're working all the way is fine. And also just a note on handwriting. Your 9 looks like your 9 and 4 looks the same.
Oh, okay.
Yeah, this should be a 4. It should be a 4. How do you continue this step? How do you continue? And when you want to make cosine the subject. Do you realize that cosine is closely related to our friend here, A dot B? Okay, you left out a tutor. How is it related? What's A dot B? Definition. 2 definition.
The AB cosine theta.
Yes, modulus of vector A, modulus of vector B, cosine theta, right over here. Can? So let's take a look at this. So we have this definition. We can make cosine. We can try to manipulate it such that it looks like this fellow here. Okay. So A dot B is divided by modulus B square. Right? So what I do is I do it step by step. Take it step by step. I want modulus. Okay, I want A dot B divided by modulus B square. So I divide by 1 copy of modulus B first, which essentially means I bring 1 copy over. I'm left with modulus A cos theta. This part okay?
Yeah.
Then now I actually want A dot B. If you recall your working, right hand side is A dot B divided by mod B square. So I need a square, means I need to divide by another copy of modulus B. Divide by another copy of modulus B, I'll get this as my answer. Is this okay?
Yeah.
So now it involves cosine theta already, so we're getting closer. But here you still got the irritating modulus A over modulus B. What else in the question did they tell you about modulus A versus modulus B? It is known that
B.
A modulus A equals to 2 times of modulus B. So that means I can do a substitution, or rather, more sophisticatedly, I can say modulus A equals to 2 times of modulus B. I divide by mod B over. Then what I get? Mod A over mod B equals to 2. Is this part okay?
Yeah.
If mod A over mod B equals to 2, here I also have mod A mod B over mod B. Substitute in, what do I get?
Cosine theta.
No, this guy becomes a 2. Wait, I write in one more extra step. Maybe you need this step. It equals to modulus A divided by modulus B times cosine theta. Do you agree?
Yeah.
Then what is modulus A over modulus B?
2.
Exactly. Then you replace it with a 2, so 2 times of cosine theta. Can see?
Oh, okay.
So this fella here is 2 cosine theta. Then I can substitute whatever you have here equals to 2 cosine theta. Make cosine theta a subject, divide by 2 on both sides. Then you're done. Can?
Okay.
Okay. Yeah. Then that's cosine theta. But this last part about part 3. Ignore it. There is a problem with the question. I tried to work it out on my own. There is a problem with the question. Please ignore this part 3. So sorry.
Okay.
Can. It's impossible for ACO and AOB to be similar. Okay. Moving on. What's the next one? Question 6. Okay, let's go. Question 6. What's wrong? What went wrong? Nothing went wrong. Good. Here, never answer the question. ATQ, answer the question. Or what my social studies like to say, ATBQ, answer the bloody question. So yeah, ATQ, please answer the question. What did they ask for? They asked for Cartesian equations. Cartesian means what? It means the XYZ version. So don't stop here at scalar product. You need to convert into XYZ. Sub the R with XYZ, get 3 equations. Can?
Can.
Okay, I'll move. Okay, can answer the question. You know how to do that. Part B. No, part 2. B part. Wait a minute. I'm confused. Oh, 6A done already. 6B part 1, make sure it's in Cartesian form. 6B part 2. Sub in. You have to show. It's. I'm a bit confused. Let me read first. A here never replaced with -3. This is not part 2. This is part 1. Yeah, don't confuse me. This is part 1. Okay. This is part 1. This is part 1. Okay. You're still answering part 1. Yeah, then you show that A cannot be equal to -1. Yes, this is correct. You want the last equation to be inconsistent. So you want the A to be not equal to 1, given these these lambda and mu values. This is fine. Moving on. Now is the actual part 2, 6B part 2. Okay. 6B part 2. Yeah, so you use pi 1, right, to name the plane, and pi 2. Technically, the question already used P to represent the name to represent the name of the plane. So you should be consistent and use P.
Oh, okay.
Use the name that they gave. Yeah. But it's not wrong. If you label your diagram nicely, you draw a bigger diagram, you write the pi 1 big, then the examiner can see. They will not penalize you for this.
Okay.
Yeah. Okay, can cross product get direction vector. Okay, this answer is correct. Take note that it's not unique because direction vector is non-unique. Can your answer can be different. I show you a different way to find a perpendicular vector. Instead of taking cross product, right? You must also know that the dot product of 2 perpendicular vectors is 0, correct?
Yeah.
So think about it. If you just pick one of the vectors, let's say 1, -1, 2. 1, -1, 2. You can just guess and check. If you want to find a perpendicular vector, you can just dot product equal to 0, and then you guess and check what should be the A, B, and C. Maybe I think it's quite easy to see that 1, 1, 0 works, right? Then that's it. Then you have found your perpendicular vector. You don't even need to take cross product. You can do R dot 1, 1, 0. Then you sub in the R with 2, 2, 0, 1, and then you solve for D equal to 1. This is also a perfectly fine equation.
So in the exam, they will accept a lot of answers.
Yes. Okay. Yes. As long as the direction, you see the direction vector, as long as it's the same, then it's fine.
Okay.
I mean, same direction. Okay. Maybe I'll leave you to work it out on your own, this part. Okay, next. 7 part 1, is it right? Find the values of A and B. Okay, the working is fine. Yes. I got nothing to say. Just draw a picture. Okay. Intersect at line L. Make sure you have a picture. Okay.
Yeah, I got a very small one.
Oh, here. Oh, sorry. Okay.
Yeah, but I don't think it's very helpful.
Yeah, you should have a line L here. You must label the L beside the line. If not, you get confused. Okay. Oh, wait, you did draw a line like that. Okay, was it helpful? I don't know. You must make it helpful. Okay. I like to draw my laptop like this whenever I have 2 planes that intersect. Okay. Then okay, your working is fine, so nothing to say. Part 3, correct, nothing wrong. Why do you circle? Okay, your answer is fine.
Oh, okay.
Yeah. Any questions? I mean, if you remember.
No. I just thought it was a bit weird because got the unknown, so I'm not sure if I'm doing it correctly.
Yeah, it's correct. This question is a bit funny, and also it's a common trend in A levels now. They will always introduce an extra letter, unknown C, unknown D. Then they don't ask you to solve for it. They just ask you to show something.
Oh.
Okay. In terms of C, in terms of D.
Okay.
Okay. Then part 4, Part 4, I already explained roughly. Okay, this one, This question is tricky because you must first know how to draw the picture first. This is the picture I explained last night. Then what you need to do here is use a trick. Take the length of projection of vector Bn onto the normal. What does that give you?
Huh?
Length of projection of a perpendicular line Bn onto a parallel vector N2. Length of projection. What does that give you?
Like the perpendicular distance.
Yes, perpendicular distance of what? Give more description.
Like it gives you Bn.
Yes, correct. It will give you Bn again. What this means is you take Bn, you take the dot product with vector n, you divide by the length of the vector n, modulus on top. This will again be the length of Bn. A bit funny, but it works. Okay, typically what we have is if I just draw a quick diagram, here's a point P, here's a point Q, then here is a normal vector. If we want to find the perpendicular distance here, the pink color one, it will be vector PQ, you dot product with vector n, divide by length of vector n, modulus on top. That will give me my, maybe I'll call this n. This will give me my Pn, which is the length of projection. But here what happens is that, okay, and also, sorry, in the original diagram, this angle here is theta, it's typically a positive angle. But over here, in this case, Bn dot with the vector n, the angle here is 90 degrees. So what this means is, if you can imagine, what we have now is point P is here, point Q is directly below it. And then you have a vector n, and then you have a point n that's the same as point Q. Okay, so the pink color line is also here. Then the angle there is 90 degrees. Can you see? The triangle gets squished into this tiny line.
Oh, so
which is actually 90 degrees means there's no triangle. There is no triangle, but it still works. The formula still works. Take the vector PQ, dot product with vector n, then you divide by the length of vector n. This working will be a lot simpler. I tried, then you can just try to get an equation in terms of C and D. You can look at the solution. Then you do simultaneous equation with the original, with the first equation, this guy. Okay. But then I tried another strategy, which is to use the fact that vector Bn, you take the modulus, it should be equal to the length, right? 5 over square root 21. Distance between the two planes. But I worked it out and I couldn't get the answer. I showed some of the working here. I crossed it out. I recommend you to not read it because it's a waste of time. I couldn't get the answer. I am not sure why. I have to get back to you. But if you use this method, it will still work.
Okay.
Can that's part 4. And yeah, we're done. Okay, good. Time to start complex numbers. Or do you need a short break?
I don't.
Don't need. Okay, good. Let's begin. Complex numbers. Okay, birthplace. Okay, I'll just do a quick one. So let's say we start off with x squared equals to 4. Of course, you know how to solve this, right? Just take the square root and then you get 2, correct?
Yeah.
Wrong. You're missing something. Plus, minus. Exactly. Okay, then you have 2 answers. So now let's say I have x cubed equals, or b cubed, just to give you a hint, b cubed equals to -1. What is b? Cube root of -1. But do you need a plus minus?
Don't need.
Don't need, because whenever you take the cube root or odd roots, you do not need the plus minus. Only when it's an even root, then you need, like for example, x power 4 equals to, I don't know, 4. Then you take the 4th root. You need a plus minus. Okay? Can but that's x aside. This is actually just equal to -1, by the way. Makes sense, huh? -1 power 3. If b is -1, do you get back to -1?
Yes.
Yes, okay, good. Now what happens if I now have x squared equal to -4? Can I still take the square root?
Cannot.
Then plus minus?
Yeah.
Before
put
complex numbers cannot, but now you can. How do you split it up? Square root 4 times square root -1, right?
Yeah.
Remember that square root AB is equal to square root A times square root B. Okay, it might not be so accurate to split it up, but I'm just going to do that. What is square root -1? It's actually just, what is it? Square root 4 is 2. What is square root -1?
The I.
Exactly. Then that's your answer. Plus minus 2i. Can?
Mm.
So the purpose of complex numbers is because square root of a negative, you cannot do that. It doesn't really make sense. So you need to force it into existence, an imaginary unit. The reason why this has a problem, x squared equal to a negative number on the right has a problem is that what you have to understand what is x squared. X squared means x times x. X times x means you have two numbers that are the same. So it can either be positive times positive, negative times negative, or 0 times 0. Do you agree? So in this case, right, what is positive times positive? It will give you a positive. Negative times negative gives you a positive. 0 times 0 gives you a 0. Can you tell me, in these three cases, do you ever get a negative number?
No.
Never, right? So that's the problem here. That's why, do you see the problem? That means there shouldn't be an answer to x squared equal to -4 before learning about complex numbers, before A levels.
Oh.
Does it make sense? Then we force there to be our answer. We force it to have an answer. We introduce the square root of -1 equals to I definition. We accept it, and then we go along with it. And it just happens to be very useful. Okay? Can that's the introduction. Introduce a new type of number. A new type of number is born, the imaginary unit. I square equals -1. Try and remember this, I square equals -1. Okay? Can? Moving on. Okay. Here's a list of my things I want to talk about the lesson plan. Number 1, birthplace. Then R is a subset of complex numbers. Okay, you know this already. And Z equal A plus BI. Basically, R is all of the numbers that you already know. Then C is basically introducing an extra imaginary unit, I. Okay, then it extends the set of numbers into a bigger set, the complex number set. C with a line. This set of complex numbers means all of the possible A plus BI in the entire world. Okay, R is a special case where the B equals to 0. A plus 0i. Does that make sense?
Yeah.
Can okay.
Do I draw with the nick at the end?
You draw an R and then you draw a vertical line like this. Does that make sense?
Yeah.
C is just C with an extra line.
Do I draw the normal I, or do I draw like
I
that?
just normal I. What is like that?
Oh, because your one like it moves like upward.
Upward? Like this?
For the scale, yeah.
Yeah, that's just my handwriting. I want to distinguish it from a J.
Oh, okay. Okay.
Yeah, you can draw a normal I. It's fine.
Okay.
Sorry, I want to distinguish from my J because my handwriting is very bad.
Okay.
Okay. Yeah, like 7, I also don't write just 7. I write with an extra line in case it gets confused with a 1 or something. Okay. Yeah. Sorry, handwriting. Yes, you don't need the extra tail, just normal, it's fine. No special notation for this. Okay, then conjugate, properties list, and dividing complex numbers and application of using the conjugate. Okay, let's just an arithmetic operation. I think I'm gonna skip arithmetic, plus minus and divide. I'll just quickly talk about it later on. Then after that, I'll go on into Argand diagram. Complex numbers as a vectors and the 3 forms of a complex number: Cartesian, exponential, trigonometric, or polar. And then after that, I talk about the magnitude and the argument. Give a short introduction, and then I give some examples, and then I will talk about the properties of the magnitude and the argument. Next one, I'll talk about the special identities or tricks. The Euler's formula, EI theta equal to cosine theta plus I sine theta. And when you substitute theta with pi, you get the most beautiful equation in math. Most beautiful, subjective. Okay, have you heard of it? EI pi equal -1 or +1 equals 0. Should have. This is from A-level H2 math. I mean, yeah,
Okay.
I'll talk about it later. Then part number 7, solving for Z. I will talk about two main types of equations that you need to know how to solve. Complex coefficients, an expression in terms of Z with complex coefficients in front of the Z and complex roots. The other one would be polynomials that have real coefficients. Okay, complex coefficient versus real coefficient. Those are really just the two types you need to know. There also used to be a third type of equation, which is Z power n equals to A plus BI. Then you have to learn how to solve this. It involves something called De Moivre's theorem, but it has already been moved to further math. You don't need to know this anymore.
Okay.
No more. Gone. Okay. Yeah, just these first two simple types. And also please keep in mind the quadratic formula. Also factor theorem. This is from O-level AMAX. Okay. Yeah, let me just list down some of the tricks you should know first. Number 1, you need to know how to use a GC. Number 2, you need to know how to use a quadratic formula. Number 3, you need to know how to do factorizing. Factorizing. Specifically, you need to know how to use factor theorem. Factorizing or grouping. And number 4 is, what is it? Oh, need to use the, oh wait, under factor theorem, you also need to know, combine it with the fundamental theorem of algebra. Fundamental. What's the fourth one? Fourth trick you must know is you must know how to compare coefficients. This is also from O-level AMAX. You did a lot of this when you're doing partial fractions or something similar, or factor theorem. Okay, 4 tricks you must know. Okay, let's just dive straight into the details now. So first one, arithmetic. We're gonna jump into arithmetic operation. Let's say you got Z1 is 2 plus 3i, Z2 is 5 plus 6i. If you add the fraction, you just add the real part with real part, imaginary part with imaginary part. Is that okay?
Yeah.
Then minus, you just do the same thing but with a minus sign. Okay? Can? Next, multiplication, you just have to do distribution. Like let's say you got 2 plus 3i times 5 plus 6i. Just do 2 times 5, 2 times 6i, 3i times 5, 3i times 6i. But just take note that 3i times 6i, you get 3 times 6 is 18, but I times I is I square, which is?
Negative
1. Oh, please remember this circle for me, the circle of imaginary numbers. I equals to square root negative 1. Next, I'm going to multiply by I. Multiply by I, so I get I square is equal to negative 1. Next one, I multiply by I again. What do I get? I get I cubed. What is it equal to? Negative 1 times I, negative I. Next one, I multiply by I again. What do I get? I power 4 equals to? Tell me.
1.
Yes, it's a 1. Correct. Negative 1 times negative 1 gives you 1. Then you multiply by I again. What do you get? You get I power 5. But what's 1 times I?
I.
It's just I. So that means I power 5 is equal to I. Then the cycle continues. Do you notice that? It goes in a cycle. So that means in general, I power 4n plus 1 is equals to I power 1. Oops. 4n means what? 4n means n is an element of let's say integers. So it means that if we are multiple of 4 plus 1, then it will just give you I. If it's I power 4n plus 2, it will just be I power 2. I power, I have no space already. Let me shrink it down. I power, next one will be 4n plus 3. It will just be I power 3. Last one is I power 4n plus 4. Well, that's really just the same as 4 times n plus 1. But what's the point of plus 1 when n is an integer? Any integer. N is any integer here. So if you plus 1, it's still an integer. So we just simplify it as 4n. Maybe I could have written it at the beginning. But this will become just a 1, if I'm not wrong. Oh, this is negative 1, by the way. This is negative I. This one will be 1. Yeah. Or maybe I should write down I power 0 because it's a plus 0, which is just 1. Can? Can I remember the circle? Oh yeah, by the way, just an irrelevant note. Circle something interesting as well. Sine x. If I differentiate, okay, I haven't talked about differentiation also. Oh no. Let's just put a D to represent differentiation. What's the derivative of sine?
Cosine.
What's the derivative of cosine?
Negative sine.
What is the derivative of negative sine?
Negative cosine.
What's the derivative of negative cosine?
Sine.
It goes back to sine. Yeah, exactly. Do you see a cycle? Got see before?
Yeah.
Got see before? Yeah, you should know this. Keep that in mind. Cycles. Not exactly relevant at A levels, but maybe useful when you're solving specific questions. Okay, so this part, do I need to explain in detail? I need to explain?
No, don't need.
Don't need. Okay, can good. That is multiplication, plus, minus, and times cover already. Now division, I will wait until I introduce the conjugate first. So what is the conjugate, number 4? Basically, you start off with z equal a plus bi. Conjugate, there's 2 ways to represent it. It's either z with a bar on top. We read it as z bar, or the line on top, over line like this. Then it's just a minus bi. Does that make sense? So plus become minus. Mic test can hear?
It is not the asterisk, that one.
Also can. Yeah, it's the same as the asterisk. Sorry. Yes, I haven't. I was about to mention. You can also put asterisk. They are the same. You will see both notations. Z star or Z bar. Okay, so let's just look at the example here. If it's 1 plus 2i, you take the conjugate, it will be 1 minus 2i. Yes?
Yeah.
Okay. But here, let's say that we have, okay, another example. 3 minus 4i, of course, conjugate is 3 plus 4i. Minus become plus. Plus become minus. Okay? Interchangeable. But now let's say we have positive 7i minus 5. What's the conjugate? Is it 7i plus 5? Wrong. You know why or not? Remember the formula. I start you off with z equals a plus bi. Then z bar or z, okay, I'll put z star equals to a minus bi. What's really going on when I say plus become minus? What's really going on is plus b become minus b. Can you tell me what's my plus b over here? Can you tell me what is it? Plus b. Is it minus or minus b? It's the 7 here, right? The number that is in front of the I is the one that will get multiplied by negative 1. So if I just rewrite it in a more standard order, plus 7i minus 5, I rewrite as minus 5 plus 7i. The conjugate is actually minus 5 minus 7i. Is that clearer now? Don't be confused. This is wrong. This is correct.
Oh, okay.
Can see, you don't just blindly see minus and convert into plus. No. That's the negative is in front of, is part of the A. Minus 5 here is the A. Then the plus B is the one that gets converted to minus B, or minus B get converted to plus B. Here it is a plus 7. You convert it into the minus 7. Clear so far?
Yeah.
Can okay, don't be confused by that. Okay, then properties list. So here's a bunch of properties you should know. When you take double conjugate, they will cancel each other off. Make sense or not? Plus become minus, then minus become plus again.
Yeah.
Can so double conjugate will give you back the original. Then here is z plus z bar will give you 2 copies of the real, 2a. Why is that the case? Check. If z is a plus bi, then z bar will be a minus bi. You add them together, what happens to your bi? Plus bi minus bi?
Cancel out.
Cancel out. You're left with a plus a, which is 2a. Okay. Then you can do something similar with the z minus z bar. Do you want me to show you? Get 2bi.
Don't need.
Don't need to show. Okay, just change to a minus and distribute, and you'll get 2bi. Okay, next one, z an element of real numbers if and only if z bar equals to c. What does that mean? It means that z is what we call purely real. You will see this in a lot of questions. You say purely real or purely imaginary. Then if and only if the z bar is a z. This is just a trick. Oh, another way to show that something is purely real is to show that the b equal to 0. Okay, this means a plus 0i, which is just a, which is the only real part. Oh, I didn't mention real part, imaginary part. You know this, right? Over here, let's say you got z equal a plus bi. Pink color is the real part. Purple color is the imaginary part. Does that make sense?
Yeah.
So let me just give a quick example. So let's say you got z equals to 3 plus 4i. The notation here is re of z. That's a real part of z. It's equal to 3. How about the im of z, imaginary part of z? What is it equal to?
The 4.
Is it 4 or 4i?
4i.
Wrong. It is 4. It is just 4.
Oh.
Imaginary part must just be a number itself. Just real number. Do not include the I.
Okay.
Cross I. Oh, cross I sounds a bit weird. No I. Okay. Can. Moving on. Next property. So z bar equal to z is because you see if z is purely real, it means that we're gonna take the conjugate of this a plus 0i. That's my z bar, which is the conjugate of a. What's the wait, sorry, maybe I should slow down a bit. Which is really just a minus 0i. Does that make sense? Which means that we will just get an a. Can you see? And of course, a plus 0i is just a. Oh, so that's why when we take the conjugate, it's and it's equal to the original number itself. Therefore, we conclude that it is purely real. This is just a trick. This is just a trick. Usually, you will just show that b equals to 0. Okay, next one. Z is purely imaginary if and only if z bar equals to negative z. Why is that the case? Let's see. If z is purely imaginary, what does it mean? It means it's 0 plus bi. Correct or not? Purely imaginary?
Yeah.
Purely imag. Then in that case, what is z bar? Let's check. Z bar will be 0 plus bi bar plus become minus. So 0 minus bi. Isn't this just negative z? Right? Original z is 0 plus bi. If you times negative in front, what happens? Negative in front, you just get 0 minus bi. Negative 0 minus bi. Negative 0, of course, you can ignore it, so minus bi.
Oh, okay.
Maybe you sound a bit confused. Negative z means negative of 0 plus bi. So you get negative 0 minus bi. Minus 0, of course, can ignore it with a minus bi. Okay? Yeah, so that's the trick. Z bar equal negative z. Can? Okay, next one, z bar. Okay, z plus w first, and then you bar the whole thing. You conjugate the entire thing. It's just the conjugate of the individual terms. Or a nicer way to say is conjugate of conjugate of a sum is the sum of the conjugate. You can hear the rhyming, right? Conjugate of sum is sum of conjugate. A of b is b of a.
Yeah.
Okay, now then next one, conjugate of product is product of conjugate. You can basically split it up. And then the last one is conjugate of a quotient is the quotient of the conjugate. Quotient means divide. Fraction is a quotient. Can? Z1 over Z2 bracket star is Z1 star over Z2 star. I don't need to copy down, by the way.
Oh, okay.
Yeah, I will send you all this.
The z plus the number 6, right? Is z plus w bracket asterisk, is it?
Yes, same. Correct. Maybe I should write it out. It should be, yes, you're correct. Bracket z plus w close bracket star equals to z star plus w star. This one likewise is z times w bracket star equals to z star times w star. Okay?
Okay.
Can. Now how to do division of complex numbers. Let's go. So what we have here, let's say we got 2 plus 3i divided by 1 minus I. I want to simplify this. Or in other words, z1 equals 2 plus 3i, z2 is 1 minus I. I want to find z1 over z2. How? I want to simplify it such that it is in this format, a plus bi, where a and b are real numbers to be found. Solve for a, solve for b. What you need to do is something we call realizing the denominator. Do you know what's that?
Is it times the conjugate?
Yes, exactly. Top and bottom by the conjugate. Why? Because you must remember a square minus b square is a plus b, a minus b, or a minus b, a plus b. Okay, so over here we have 1 minus I. We are going to multiply by 1 plus I top and bottom. Conjugate of 1 minus I. Conjugate the denominator, not the top. So what happens? You get 1 square minus I square. Let me review the answer. Like this. After multiplying by the conjugate top and bottom, you get 1 plus I at the top. But bottom, I just skip a step. 1 minus I times 1 plus I, straight away you get a square minus b square. So 1 square minus I square, which is 1 minus negative 1. Is this part okay?
Okay.
And then this part I multiply 2 times 1, I get a 2. 2 times I get 2i. 3i times 1, I get 3i. 3i times I get negative 3. Negative 3. Is this part okay?
Yeah, can.
And next, then 1 minus 1 is 1 plus 1, which is just a 2. Simplifying, I get this guy here, 2. But the numerator, 2 minus 3, I get a negative 1. 2i plus 3i gives me a 5i. Then I can now split it up. You know, right? If it's like, for example, in normal algebra, minus 1 plus 5x over 2, I can split as minus 1 over 2 plus 5 over 2x. This part, okay? So now you just replace the x with an I, you'll get the final answer, which is negative half plus 5 over 2i. A equal negative half, b equals 5 over 2. So far, so clear?
Yeah.
Okay, good. That is division. Let's try, okay, another example I won't go through. I think you understand. Okay, you can go look this on your own. You can read this on your own. But at the end of the day, if I take 1 plus 2i divided by minus 3 plus 4i, I will get this guy, 1 over 5 minus 2/5 I. Then what I want to bring up here is that the real part of z over w is 1 over 5. Imaginary part of z over w is minus 2 over 5. Right?
Yeah.
No I, no I, no I. Okay, in this case, that's all I want to say. Nothing. Okay, moving on. Next one, another practice question. Okay, I think I'm gonna skip this. I'll just quickly explain. When I see 17 minus 6i and minus 4 minus 12i with a bar on top, it means that I'm going to convert my minus into a plus. Correct? Mic test, can hear?
Yeah.
Correct. Bar means conjugate. I'll just convert the minus into a plus. Then now you just multiply those two, you'll get the answer here. Sorry, the answer here. 4 plus 2 to 8i. I don't want to go through this. You can read on your own. Next.
Oh.
Yeah, skip. This one you know already. Then this one, division. Okay, I'm gonna skip this. I'll leave this for you to read on your own. Is that okay?
Okay.
Okay, division. I'm sure you know how to do this. Just make sure you remember to rationalize denominator. Okay, maybe this part I go through a little bit. Minus 4 plus 8i already is at the denominator. What's the conjugate?
The minus
Minus
4 minus 8.
Minus 8i. You don't blah blah and write down for me plus 4 plus 8i. Minus turn into plus. That's not correct. Okay, it should be the number in front of I, change the sign. So plus 8 become minus 8. Is that clear?
Okay, yeah.
Also, make sure that it's the denominator. Oh, by the way, let's say that I have a 2 over 5i. What should I multiply by? Top and bottom. One way that you could do it, in this special case where it's just an imaginary unit, you can interpret as 0 plus 5i. So you can multiply by the conjugate, which is 0 minus 5i. Is it just at the bottom?
Oh, no.
At the top as well. But what do you notice? If you want to realize the denominator, you just need to get rid of the I. Don't you see a faster way? Instead of negative 5 over negative 5, sorry. Let me find the right page. Do you see a faster way? Alternative strategy. How about if I just multiply by I over I?
Also can.
Also can, right? It's a lot faster, right? 2i on top. I times I is I squared negative 1, 5 times negative 1. Which is 2i over negative 5, negative 2 over 5i. If I did the other way, I have to do 2 times 5. Then if you suddenly brain freeze, you do 2 plus 5, then you get 7. then negative 7i. Wrong.
Mm.
It should be negative 10i. Then you divide by 5i times negative 5i, negative 25i times I is I squared, which is really just, okay, I'll leave the working alone. Negative 10i over negative 25 times negative 1. And then eventually you get back to the answer here. Both ways work,
Okay.
but this is faster, just to let you know. But you use this is not wrong. Okay?
Okay.
Okay, next thing I want to talk about. Let's say I got the correct, okay. Let's say I work with this answer here. This is answer here, 2 plus 3i divided by 1 minus I equals to minus half plus 5 over 2i. How do I use a calculator to solve this? Let me show you on a GC. Hold on a second. Let me load up this GC. Okay. Give me a second.
Okay.
I just started a new screen share. Can you join?
Yes, can see.
Can see the GC now? Okay, good. Let's go through. Second, quit. Okay, how do you do division? Let's say 2 plus 3i divided by 1 minus 3i. If you decide to use a fraction, because you want to make it look nice, let's see what happens. 2 plus 3 second I divided by 1 minus I. 1 minus second I. What happened?
Cannot.
Why cannot? Divide cannot. When you write it as a nice fraction, the calculator GC somehow is not able to interpret this. So what is the solution? The solution is simple. You must do it the manual way. Open bracket 2 plus 3 second I, close bracket. Then you press the divide symbol. Open bracket, what's the denominator? It's a 1 minus I. Okay, I'm not sure if you copy down the example, but yeah, this is, I'll just tell you lah. Okay, you must write it in this manual way with the brackets. Okay, bracket around the numerator 2 plus 3, and then bracket around the 1 minus I. Can? And then you press equal, you'll get the answer. Ta-dang. Oh, decimals. I don't like decimal. I want fraction. How? Press the math button. You see number 1 FRAC?
Yeah.
Enter. Answer arrow fraction. Answer here, ANS means you're storing the minus 0.5 plus 2.5i. What happens if you press enter?
Ooh.
Convert into fraction for you. Another way to access the fraction function is press alpha and then press either of these buttons. Let's say 1 by 1. Then you access all these extra functions. Here is the conversion. Here, if you choose like number 2, UN/D means you're converting into mixed number. So you can press that, number 2. Oh, you get a fraction. Okay, that's not what I meant to do. Sorry. Alpha Y1. Let's see if I have the function. This one, number 3. This one will help you to convert from fraction into mixed number. Let me try that again. Oh, it's the other way around. From fraction into decimals. Okay. Never mind. Just learn this function can already. Answer to fraction. Sorry for confusing you. Just press math and then number 1 for fraction.
Okay.
Math for that. That's very useful. Okay, let me just change my screen. Hold on a second. Yeah, just remember, don't use the fraction function, do it the old-fashioned style. Bracket, and then do the manual divide symbol. Using GC. You can also take square roots and cube roots with a calculator. Later, then I talk about it. Okay, moving on. Argon diagram, let's go. So complex numbers is approximately like a vector. So there used to be this topic known as the locals. And it required a heavy use of the sorry, I forgot to resume share. Can you see my screen?
Can.
Okay, there used to be this topic called locus, and it required heavy use of the Argand diagram. But for now, the modern syllabus, you no longer have the locus, it's in further math now. So Argand diagram, you just need to know the basics can already. Here, complex numbers, the first thing I want to talk about is that it is very similar to a vector. A complex number is essentially a vector. So it's something like this. Okay, here you have x and y axis, right? But it's actually no longer x and y. It should be a real axis on the x and an imaginary axis on the y. And this xy plane that got replaced with the real and imaginary plane is what we call the Argand diagram. Argand is a mathematician, and he created this, so that's why it's called Argand diagram. Can?
Oh, okay.
And yeah, so it's like a vector like this, starts from the origin, like a position vector. And it can be represented by a certain point. Let's say point P to represent the vector, to represent the complex number Z. Okay, then number 2, 3 forms of a complex number. So these are the 3 forms over here: A plus BI, R E I theta, and R cos theta plus I sin theta. I'll talk more about it later. Okay, later. Then there's magnitude and argument, introduction and properties. I'll also talk more about it later. Now we focus on complex numbers being a vector. So here's an example. Let's say that you have a complex number Z equal 3 plus 3i. So what does it mean? It means that you start from origin and you travel 3 units to the right and 3 units on top. Okay, and then there's a certain angle here. It must always go from the positive x-axis and you turn either anti-clockwise or clockwise. Okay, that's the angle, the theta, also known as the argument. And what else you have? You have the length of this vector, or rather the complex number, and that will be the magnitude. Later, then I talk about the formula. It's the same as vectors. It's the same formula as vectors. Yeah, and how we can describe this tree and this tree is the real part and the imaginary part. Also, you can think of it as the horizontal length and the vertical length. Okay, that's a real part and imaginary part. But of course, it's a signed length, meaning you must include plus or minus sign. If let's say, for example, you have another one, 3, -4. Then that means that here is length 3, here is length -4. This complex number is 3 minus 4i. Then the real part of Z is 3, but the imaginary part, you must include the negative sign, so it's -4. Is that okay?
Yeah.
Then where's the angle? Is it this angle, big one, or is it this one?
The small.
The small one. And what do you notice? I always start from the positive x-axis, or rather the real positive real axis. Then I turn anti-clockwise, like this. Okay, that's my theta. Okay, moving on. Principal range. What is principal range? Principal range is basically saying that the angles in complex numbers they must always be in between -pi and pi, inclusive of pi. Okay. I'm not sure if it's in no, it doesn't include -pi. Okay, must have pi. So every time you have an angle that goes beyond this interval, you have to add or subtract multiples of 2 pi to bring it back in. Is that okay? Okay, and now just a side note, I'm gonna talk about not a side note, you need to know this. Solving trigo equations in general. In the general form. So let's say you have a sine of, let's say you get sine of theta equals to half. So what is theta?
Sine like inverse half.
Correct. But okay. Yes, 1 square root 2. That's not a right triangle. Next one, it should be 1, 2 square root 3. 60 degree, 30 degrees. So I think you can see that it's really just opposite over hypotenuse. So sine 30 degrees will give you half, right?
Yeah.
Yes.
Yeah.
So that means that this is actually just 30 degrees, but I want radians, so pi over 6. Now, this is only true if you're finding the quadrant 1 angle. Remember ASTC?
Yeah.
If you get positive, let's say the angle is in between 0 and 360 degrees. Or rather, if I use radians, it should be 0 to 2 pi. Then what would the other angle be? What? Okay, sorry. Maybe I should slow down a bit. I shouldn't conclude theta equal to pi over 6 so fast. I should say alpha, the acute angle, is sine inverse of the half, which will give me the pi over 6. This is what I call the basic angle, or basic angle or reference angle. Do you know this?
Yeah.
Yes, huh? Then therefore theta is actually just the basic angle, or what's the alternative? Quadrant what? The
Two.
other quadrant 2, right? Because S here is positive in quadrant 2. So you also have a positive, which means that your other possible angle will also be in quadrant 2. How do you find your quadrant 2 angle?
180 minus.
In radians will be pi minus. Right?
Oh.
Then you get pi over 6. Okay, that's good. But that is only when the angle is restricted to 0 to 2 pi. Let's say now I change it, so it's unrestricted, any theta. Then this will no longer be true. Okay, sorry. No. I have to keep them, but I have to extend it. You know, right? You can have angles. If I add on 2 pi or I subtract 2 pi, multiples of 2 pi, the angle will still be the same, right?
Yeah.
Yes, right. So in general, the general solution, you now have to rewrite it as theta equals to the two answers you found, but you have to add on multiples of 2 pi. So it's 2 pi times n. Same thing over here. It's just theta equals to 5 pi over 6 plus 2 pi times n, where n is a integer. Can be plus 1, 2, 3, 4, 5, 6, 7, 8, or -1, -2, -3, -4, so on, and as well as 0. N can be any of these numbers.
Oh, okay.
This is the general solution. Can understand?
Can.
Can. So okay, let's say that now I have theta to somehow be equals to 2k minus 1. Okay, where k is a integer that you want to solve for. So let's say now you got 2k minus 1 equals to pi over 6 plus 2 pi n. Okay, let me think a bit. Maybe this is not so good. Okay, never mind. I won't talk about it. Never mind. I'll go into it when we get there. You know how to solve the general solution already? This too?
Solve? Yeah, like
I mean, yeah, this is finding the theta. Can already,
Can.
Can. Okay, good. Just remember to add on the 2 pi n. Multiple of 2 pi. Another one that I want to talk about. Okay, I think maybe another time. I don't go into too much detail. So you just need to know there's a general form. You need to add on 2 pi n. This was not in A max. It's in A levels only. Okay, moving on. We talk about the 3 forms of complex numbers. Okay, z equals to a plus bi, z equals re I theta, z equals to r times cos theta plus I sin theta. Then you can multiply the r in, you get r cos theta plus I sin theta. These are your 3 forms. Okay, so first thing you must know is ei theta equals to cosine theta plus I sin theta. Have you seen the proof before? Maclaurin series. You can expand it in Maclaurin series.
Oh, yeah.
Then sine, you do the same thing, but you times I. Then you add them all together, you realize it's the same as the Maclaurin series of the e power of the exponential. You've seen it before? I'm going to skip it.
Yeah.
Okay, so this is the proof. This is the conclusion of that proof. Then what happens if I substitute theta with pi?
It becomes cosine pi plus I sin pi.
Simplify. What's cosine pi?
0.
0. Eh? Wrong. Wrong.
Huh? It's not 1. Oh, it's -1.
Yes. How about sine pi?
0.
Yes, correct. 0. Okay. Then you simplify, what do you get?
Become -1.
Yes, correct. So ei pi equals to -1, or you bring the -1 over, you get ei pi plus 1 equals to 0. This is the most beautiful equation in math. Why? Because it contains all the branches of math. Exponents, imaginary number, complex numbers, pi, irrational numbers, area of circle, plus basic addition, plus 1 and 0, the binary numbers, and an equal sign, equations which are found in math. So it contains many branches of math all in one equation. Okay, yeah, that's just a side note. The main thing here is that you can always rewrite it as cos theta plus I sin theta over here. Must memorize, can? Can, okay, good. Then these are our three forms. Let's just go into an actual example. So let's say, okay, that's the picture. Honestly, not that important. Let's just focus on this guy. Z equal to 3 plus 4i. Okay, so what's the magnitude? The formula here will be square root of a square plus b square, similar to complex numbers, right? I mean, similar to vectors, right?
Yeah.
A square plus b square plus c square. This is just simpler. So square root sum of the square, and you get the square root 25, which is 5. Okay, that's your magnitude form. How about argument? Argument means you go and find the angle over here. The angle over here. So 3 plus 4i is what? Where is it? It's somewhere over here. 3, 4. Then the angle is over here, right? So it's quadrant 1. You just need to take tangent inverse of 4 over 3. Can you see that? 4 here, 3 here.
Yeah.
Tangent inverse. Can tangent of theta is opposite over adjacent, right? So opposite over adjacent. Solving for theta, you just need to take the tangent inverse to get theta. Okay, moving on. Make sure your calculator is in radian mode so you can solve for answer in radians. Then therefore, since you have found your modulus as well as your argument, you can substitute into the exponential form of the complex number, which is REI theta. R in this case is 5, theta being 0.927. Is this okay?
Yeah, can.
Then we know that EI theta is what? The formula.
Or the cosine theta plus I sin theta.
Yes, correct. Cosine theta plus I sin theta. So therefore, you get cosine of that angle theta plus I sin of that angle. Is this clear?
Oh, okay.
Can? Then you can just multiply the 5 in if you want to. So 5 times of cos 0.927, 5 times of I sin 0.927. I just brought the I to the right side. What do you notice about 5 cos 0.927 and 5 sin 0.927? Type in a calculator. Radian mode. Radian mode. Let's check. 5 times cosine of 0.927 is?
Oh.
Huh?
3?
Yes, it's 3.0011, blah, blah, blah. Yeah, so it's really just 3. It's really just the real part that we started off with. Can you see that the same? How about 5 sine 0.927? Make a guess. What do you think it should be?
4.
4, exactly. It should still be the same. Let's type in the calculator to check if it's correct.
It's 3.999.
Yeah, 3.999. So it's approximation because I cut off already. I truncated the answer. Okay, 0.927. I rounded off. Okay, so yeah, it should actually be the same. Just to take note. Okay, that's how you convert between the three forms. Is that okay?
Yes, can.
Maybe I should also label. This one is exponential. This one is trigo. That one is Cartesian. Okay, the three formats of a complex number. Clear so far?
Yeah.
Okay, good. Next. Now, magnitude and argument. We're gonna consider 4 different cases. This is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Okay, 4 different cases. Yeah. So let's begin. So let's start with quadrant 1. How do you find, let's say, square root 3 plus I? How do you find the magnitude and argument? Just square root a square plus b square, square root 3 square plus 1 square, you get a 2. Then arguments here, you just take tangent inverse, right? Over 3, you get pi over 6. Okay, can this angle? Can. Moving on. Quadrant 2, now it's a bit challenging. Quadrant 2, when you have a complex number that's ending up in the quadrant 2, what is the angle? You have to start with the positive real axis and you turn anti-clockwise. That arc, that arrow curve that I just drew is the angle theta. How do we solve for angle theta? What we do is we find the basic angle first. This green color is the basic angle. Can see green color. And how do you find the argument? Okay, modulus, I'm not going to talk about it. It's obvious. You can go read it on your own. Argument Z will actually be what? This angle here is how many degrees? How many radians? Sorry.
100 pi.
Pi radians, right? When you go anti-clockwise. But that means that this red angle, is it bigger than pi or smaller than pi?
Smaller.
So you have to plus or minus from pi.
The pi minus the basic
Pi
angle.
minus. Yes, correct. Pi minus basic angle. Do you know how to find basic angle?
Yeah.
The trick here, you just take the y over the x, but you make sure that everything becomes positive. Okay, drop all the negative signs. Type in the calculator, you'll get 2.1587. Is that clear?
Okay.
Next one, quadrant 3. Oh no, now it's quadrant 3. It's ending up in this corner over here. Let's find out. Let's look at this example. -2 minus root 3i. What is the magnitude? Square root of? Can you tell me?
The 2 square and
Plus
the negative 3 square.
Root 3 square. Okay. Be a bit more precise on root 3. Then of course you can drop the negative because you're squaring, it becomes positive. That's a 4, that's a 3, 4 plus 3 is 7, so square root 7. Okay?
Can.
Okay, how about argument? Take note, when you go from end up at quadrant 3, you're supposed to start from the positive real axis and you turn clockwise instead. You see, the trick here is you must always start with the real axis. Then the question is, do you turn anti-clockwise or clockwise? Here's how you memorize it. Always pick the smaller guy. Look at the direction you turn for anti-clockwise versus the angle that you turn for clockwise, which is smaller.
Oh, the clockwise.
Clockwise one. So you always pick the smaller one. Take a look at the quadrant 2 one. In order to reach this line here, you start with the positive real axis. Do you turn clockwise or do you turn anti-clockwise? Anti-clockwise. Why? Because the angle here is
smaller.
And of course, the quadrant 1 is obvious. You turn clockwise or you turn anti-clockwise, which is smaller?
The anti-clockwise.
Anti-clockwise one is smaller. Okay, good. Always pick the smaller angle. Okay, so quadrant 3 first, we zoom in later, then I talk about quadrant 4. So smaller angle here, that's the angle theta. But what about this huge angle here? Is it pi or negative pi?
Like it's still pi.
No, with respect to the direction, it's actually negative pi. Wrong, not pi, it's negative pi. Okay, the direction matters. Anti-clockwise is always positive, clockwise is negative. This one must memorize.
Oh, okay.
Okay, so this is a negative angle. So this is actually negative pi radians. Okay, this is negative pi radians. So let's try to figure out what is this angle here. How I would do it is I will just interpret this as pi, and then I minus away the tangent inverse of this base to get the basic angle, and then I multiply by negative throughout. Do you know what I'm saying?
Multiply by negative throughout.
Yes, so I put a negative square bracket first. Then I pretend that this is sort of like in quadrant 2. I just take pi minus away the basic angle. So pi minus away basic angle, which is tangent inverse of rise over run. Look at this right angle triangle. What's my fraction? Rise over run. I mean, sorry, opposite over adjacent.
So it's square root 3 over 2.
Correct, yes. Good. Okay. This one over that one. Root 3 over 2. Maybe it will be nicer if I just label here. Maybe in a different color, just in case I get confused. This is square root 3. That is a 2. Okay, good. Yeah, then that's then you can key in the calculator on your own. I don't care about the answer. I care about the method. Do you understand this method?
Yes.
Can I? Of course, it's the same as negative pi, then add on the tangent inverse, which you can interpret as negative pi first, and then you add on. Every time you minus, you have to turn clockwise. Every time you add an angle, you have to turn anti-clockwise. Can you see? I turn anti-clockwise here, then I turn clockwise here.
Oh.
Minus away pi, which means I turn anti-clockwise by 180 degrees. Then plus, so I turn clockwise by the tangent inverse, root 3/2.
Okay.
You can interpret it that way. Or you can do it my style, which is a negative first and then pi minus the basic angle. Pi minus away basic angle. Okay, moving on. Last one, quadrant 4. This is quadrant 4. How do you find the modulus? Let's go 1 minus I. So it's square root.
The 1 negative 1 square plus 1 square.
Yeah, same thing. Okay. A plus bi, a square plus b square, or b square plus a square is the same. Okay. Square root, you get square root 2. Okay? Can? Good.
Yes.
Argument?
It's like negative 1 over 1.
Wrong, eh? Something inverse. What inverse?
Inverse? I mean it's tangent inverse negative 1 over 1.
Yes, you didn't mention tangent inverse.
Yeah,
Okay, tangent.
The number.
Sorry, yeah, tangent inverse. What is it? Tangent inverse of what over what?
Negative 1 over 1.
Wrong. I don't want you to do
It's
that.
1 over 1. 1 over 1.
I do not want a negative in my tangent inverse, only positives. Likewise for sine inverse and cosine inverse. Then after that, what's 1 over 1? You're actually finding out this green color angle, right?
Yes.
That green color angle in terms of not the positive or negative orientation, just the angle itself. But here, look, the angle of magnitude, you can see, right? You start with the positive real axis, you want to reach the line. Do you turn anti-clockwise or do you turn clockwise?
Clockwise.
Clockwise because it's smaller.
Yes.
This is a huge angle, this is a small angle. So you pick clockwise. Clockwise positive or negative?
Clockwise is
Forget already.
positive.
Wrong, negative. Yeah.
Oh, I
Clockwise is negative.
Oops.
Okay, just remember it like this. Maybe it will help you. There are 4 angles here. These guys at the bottom of the x-axis is negative.
Oh, okay.
Right? And on top is positive. So here, you see quadrant 4 is below the real axis, so it's at the bottom, that's why it's negative. Okay, but more generally, clockwise is negative. Clockwise is negative. Anti-clockwise is positive. Can? Okay, then since this tangent inverse is just a basic angle, which is and the fraction here is in absolute value terms, which is all positive. It means that the tangent inverse here is just a positive acute angle. But we actually want a negative. So that's why we force the negative on our own, because we know it's in quadrant 4. Then we put down an extra minus here on our own. Can?
Okay.
That's how you find the angle in quadrant 4. Argument is difficult to find. You need to think a bit. Which quadrant are you in? Clockwise or anti-clockwise? The trick here, the procedure here is you must draw the diagram, draw the right angled triangle, then label your red color arrow followed by a theta. Then you'll be able to tell that, oh, this is clockwise. Then what is the corresponding angle to find? You need to always take tangent inverse of opposite over adjacent, but must make sure that it's always positive. And then after that, to get your basic angle already, and then you add on the extra pi minus, pi plus, or negative on your own. Okay, I've shown you all 4 cases, which is all 4 quadrant angles already. You can go and figure it out on your own for other examples. Okay? Can. So let's just write this down. Always positive. Okay, can. Next one. Properties. Okay, this one very important. Let's go to properties. So Z1 equals to R1 cosine theta 1 plus I sine theta 1 is a complex number, followed by a second example of a complex number. Z2 equals to R2 multiplied by bracket cosine theta 2 plus I sine theta 2 close bracket. What we're going to do now is we're going to list out all the properties of the modulus. Let's take a look. First one, when you have a product of a modulus, is the when you have the modulus of a product of complex numbers, it's the product of the modulus of the individual complex numbers. Or more succinctly, modulus of product is product of modulus. Okay? And of course, because we got Z1 is R1 times something, and Z2 is R2 times something, so we can simplify as R1 times R2. Mod Z1 is R1, mod Z2 is R2. Okay? Then likewise, mod of a quotient is quotient of the mods. Modulus of quotient is quotient of modulus. So modulus of Z1 over Z2 is just modulus Z1 over modulus Z2, which is R1 over R2. Is that okay?
Okay.
Then over here, one more. When you got a power n, you can just take out the power. Z1 square, for example, if n is a power 2, okay? N element of integers starting from 0, but you only consider the positive integers. So let's say, for example, n is 2. So Z1 square, you take the modulus. It's actually just the same as modulus of Z1 and then square the whole thing outside. Can? Can, Okay, good. Moving on, argument properties. It looks like logarithm. Argument of Z1 times Z2 is argument Z1 plus argument Z2. So product to sum, just like logarithms. Okay, so in terms of Z1 and Z2, it will be theta 1 plus theta 2 in terms of the R1 times cosine theta 1 plus I sine theta 1, as well as the theta 2 version. Then, what went wrong? Wait a minute, let me bring it back. And then you have Z star, that's the conjugate. When you take the argument of the conjugate, it's just a negative of the argument of the original Z. The reason being, this is outside of a syllabus, but I'm just going to give it to you. If let's say you have a complex number like this is Z. Okay? Can see?
Okay.
Mic test, can you hear me? Can. What is the Z star? How does it look? Okay, can. Oh, I think there's a lag. Mic test, can you hear me?
Yeah, I think so. Yeah, or my mic very soft. I'm not sure.
Oh, maybe you were not speaking into the mic. Okay, this is Z. How about Z star? Where is Z star? If Z is A plus BI, Z star must be A minus BI, right? So how do you actually reach to this point? It's actually A units on the real axis and B units on the imaginary axis. Oh,
Yeah.
can you see? So that means that where is A minus BI? It's really just negative B here, right?
Yeah.
Then where is A minus BI? It's actually over here.
Oh, so it's a reflection.
It's a reflection. Technically, this is outside of your syllabus. You're not supposed to know this, but I'm just gonna tell you anyways. Then reflection. So what's the angle here? Is it still theta? No, it becomes negative theta. Quite obvious, right?
Yeah.
Just reflect. That's why you have this. That's why this property here is true. Even though this topic has been removed from your syllabus, but you're still expected to know this argument. So just memorize. If you cannot understand this, memorize this. Argument of Z star is negative of the argument of the original.
Okay.
Can. Good. Then next one, argument Z1 over Z2 is argument Z1 minus argument Z2. Take note, division become subtraction. Okay, maybe this one I should say product to sum. This one is quotient to difference. Basically, divide become minus. Okay? Times become plus. And of course, theta 1 minus theta 2. Then this one, power n, you can just bring the power down, just like power rule. Doesn't it look very familiar? Log ln, let's say ln of 5 power 3 is just 3 times ln 5.
Yeah.
Right? Logarithm rules? Same thing. It looks very similar. Argument is almost exactly the same as logarithm rules. Okay. Then some warnings. These are wrong things to do. You take the modulus of a sum or a difference, you cannot just split it up. This is wrong. Likewise for the argument, you cannot split it up like that. When it's a plus minus, you can't really do anything. When it's a plus minus, you can't do anything.
Oh,
You need to do some special tricks.
okay.
There are questions that ask you about that. Okay, so for example, if z1 is 1 plus I, z2 is 2 minus I, add together, you get a 3. So what's the modulus of z1 plus z2? Since it's just 3, which is 3 plus 0i, the length is just 3 lah. You can draw a Venn diagram, Argand diagram. This is 3. Then this will be your vector. This is z1 plus z2. Then what's the length of z1 plus z2? That's just a real number. It's just length 3. Or if you really wanted to, you can write down square root 3 square plus 0 square. But this, I think, shows a lack of understanding of what's a 3 plus 0i on the Argand diagram. You should draw the diagram, see it, and it's quite obvious that the length is just 3. Okay?
Okay.
Just length 3. Okay, then how about mod z1 plus mod z2? It becomes modulus of 1 square plus 1 square from 1 plus I. Add on modulus of 2 square plus negative 1 square. So what does that give you? Square root 2 plus square root 5. Is that equal to 3? It's not equal to 3. So that's the main point I'm trying to drive here. Modulus of z1 plus z2, it is not equal to mod z1 plus mod z2. You cannot split it up like that individually. Okay, we can do a quick one to find the argument as well. This one is not true as well. Let's see. So argument of z1 will be what? Tangent inverse of 1 over 1, 45 degrees, pi over 4. Argument of z2 is what? 2 minus I. So which quadrant is it in? 2 minus, so somewhere here. Turn anti-clockwise. 2 here, 1 here. So it will be tangent inverse of 1 over 2. And then you have extra minus sign because you're in quadrant 4. Type in the calculator to get an answer. Let me see. Tangent inverse 1 over 2 with an extra minus in front is a negative 0.4636. Okay, that's argument z2. We are not done yet. Now we need to look at argument of z1 plus z2, which is really just, let's take a look. What's z1 plus z2?
Three.
It's 3. So what's the argument here from the Argand diagram? Nothing. Where's the theta? I cannot turn anti-clockwise and I cannot turn clockwise. So what's the theta?
0.
0, exactly. So it's just 0. Then let's check. If you tell me that argument z1 plus z2, okay, so what we realize is that argument z1 plus z2 is 0, which is not equal to negative 0, pi by 4 plus negative 0.4636, right?
Yeah.
Maybe I should write this equals 0, which is not equals to pi over 4 minus 0.4636, which itself is equals to argument z1 plus argument z2. So the conclusion basically is that you cannot split up into the sum. Okay?
Yeah.
This one. You cannot distribute the argument. Likewise, you cannot distribute the modulus. Okay, this is the main conclusion. I showed you for the plus version. You can try on your own for the negative. You will get some examples that just don't work. Okay, now there's a warning. Please don't do this. Don't go and split it out like that.
Okay.
Okay, later on we'll be doing modulus questions, examples. More examples. Okay, I'm gonna skip that. Whatever. Okay, let's do a actual example here. I'm sorry if it's a bit dark. Can you see?
Can.
Okay, let's read the question. The complex number z has modulus 2 and argument theta, where theta is in between pi by 4 and pi by 2. The complex number w is such that w is equal to z over 1 minus I. In an Argand diagram with origin O, the points P, Q, and R and S represent z, w, w minus z, and negative I times w respectively. Part A, find the modulus of w and the argument of w in terms of theta. Modulus of w here means that you want to find mod w over here. But we know what is modulus w. It is just modulus of the original. Modulus of the original z over 1 minus I. Correct?
Yeah. Correct.
But z is a complex number. 1 minus I is a complex number. So we can split it up. So modulus of a quotient is quotient of modulus. So modulus of the top guy, modulus of the bottom guy. This part okay?
Okay.
But what's modulus of z?
2.
2, right? It's given. So you can replace numerator with 2. Then modulus of 1 minus I, just use the formula. A squared plus b squared. Simplify, you get a square root 2.
Mm.
2 over square root 2. Yeah, you get square root 2. Okay, good. That's the modulus. Not done yet. Let's find the argument now. Argument of W is what? It's just argument Z over 1 minus I. When you got a quotient, can you split it up? Is it the same as argument Z on top and divide by argument 1 minus I?
No.
No, cannot. Okay, maybe I should include that in my warning as well. No space. Let me shrink this down. Include more warnings. I'm very afraid that you'll make this kind of mistakes. Please don't. Modulus of Z. No. Argument of a quotient is not quotient of the arguments. This is wrong. It's just like how logarithm of A over B is not the same as log A minus log B. Remember, this is wrong?
Yeah.
This is wrong. Okay, just to take note. Okay. If you got more misconceptions, just make sure you write down some notes. Right? Buy a notebook and list down all the silly mistakes that you make during your practice questions. List them all down, and then you will eventually be able to not make those mistakes. Okay, so here you got quotient. You can split it up into a difference. So arc Z minus arc 1 minus I. But what's argument of Z? Let's read the question. They told you argument is
theta.
Theta. So you can that's all you can do. Leave your answer in terms of theta, right?
Oh, okay.
Yes? So you can just use theta. But what is argument of 1 minus I? Let's take a look. Argument 1 minus I. Where is it? Over here, right?
Yeah.
So we want to find this angle. So it will just be negative of the tangent inverse of, they use the -1. I don't like this.
Yeah.
So I prefer it if you just write it like this. Okay, I'm gonna redo this. Equals to theta minus away argument 1 minus I will be negative of the tangent inverse of a positive ratio. In this case, it's 1 over 1. Okay.
Okay.
Okay, then simplify, you get theta plus tangent inverse of 1 over 1, which is actually just 45 degrees, pi over 4. Let's see if my answer is correct. It's the same. Okay.
Okay.
So in this case, the angle is they are just telling you that you have to make sure the angle stays within the negative pi and positive pi. I think I mentioned it just now already. Here it is still within that range. I think so. Why? Because let's take a look. They told you that the theta is in between pi by 4 and pi by 2. So let's work it out, the inequality. And we have theta, but we add on a pi by 4. So we have to add on pi by 4 to both sides, to all sides of the equation. Sorry, of the inequality. Which means that we'll be left with pi by 4 plus pi by 4 is just pi by 2. Less than theta plus pi by 4. Less than this one is 3 pi over 4, is it? Guess?
Yes.
Half plus 1/4 gives you 3/4. Okay, so therefore you get angle theta plus pi by 4 that's more than pi over 2 but less than 3 pi by 4, which means that in turn they are inside the interval of negative pi to positive pi. Yes?
Yeah.
So it's safe. since you're still inside, you don't need to add or subtract multiples of 2 pi. Sorry, I think it was blocking. Can you see it now?
Yes, can.
Can I? Yeah. So they are the same. I'll send you the file later, so don't worry if you can't copy in time. Yeah, that's exercise on the modulus and argument. Next thing, special identities. Okay, Euler's formula, talk about it already, and the most beautiful equation, substitute theta equal to pi, talk about it already. Next one I want to talk about is quite important. This one will always be used in application questions. Let's take a look. EI theta minus way e to the power of negative I theta is just 2I sine theta, as well as EI theta plus e power negative I theta is equal to 2 cos theta. Okay, pick one. I'm only going to go through one of them. Which one do you want? Left or right?
Left.
Left, huh? Okay, then the right one, you're going to read it on your own. Let me know if you got trouble with it. So, alternatively, you can also replace the theta with an x. Oh, I think this version will be more useful later when we are using it. Because the theta may change into a 2 theta or some other angles. But never mind, we just prove the original form first. So let's start with the left-hand side. It's EI theta minus e power negative I theta. So it's really just e power I times bracket theta and bracket negative theta. So the angle, the argument here is a theta and a negative theta. Agree so far?
Yes.
Argument, I highlight. So that's why we can convert this exponential form into the trigonometric form. If you remember, e power I theta is equal to cos theta plus I sine theta. So cos theta plus I sine theta. This part okay?
Yes.
First term. Minus bring down, minus bring down. Bracket, there's an invisible pair of brackets. There's always an invisible pair of brackets after a minus sign. Just for your information, in case you didn't know. Then this EI negative theta will be what? Is it still cosine theta plus I sine theta? No. You have to replace the angle with negative theta correspondingly. Is that okay?
Yes.
And now, do you recall cosine of negative theta is just cosine theta? Do you know this?
Yes.
And sine of negative theta is negative sine theta?
Yeah.
Yes, so you can do the same thing over here. Cosine negative theta will just be cosine theta. Sine negative theta is extra minus sign outside, then sine theta. Which means that if I multiply by this positive here, I will get cos theta minus I sine theta. So far, so good?
Yes.
Okay, but don't forget, left-hand side, nothing happened, just copy and paste. Don't forget that there's a minus bracket bracket, so you have to distribute the minus sign. What happens? You get minus cos plus I sine. What happens to your cosine theta?
Cancel out.
Cosine minus cosine, you cancel off, you're left with I sine theta plus I sine theta, which is 2 copies of I sine theta, which is your RHS, proven. Can? Okay, likewise, you can get something similar with the other guy. It's just that I change it to a plus. Change it to a plus. And then you'll get a different identity. This time the I sine theta cancels off. You're left with 2 cos theta. You can go read on your own. Can?
Okay.
Okay, those are the 2 identities. Now we learn how to apply those 2 identities in this question. Let's take a look at example 5. You have a complex number w given by this fellow. 1 minus e power negative 4i theta over 1 plus e power of negative 2i theta. 0 less than pi, theta less than pi over 2. You want to express w in both Cartesian form and exponential form. This is quite challenging. But don't so if you don't know a certain famous trick, you will struggle a lot. Let me show you one way that you could do this, which is a not recommended way. W equals 1 minus e power. Let me copy the question first. Here is one non-recommended way to do it. You can interpret this as 1 minus e power I times negative 4 theta and 1 plus e power I times negative 2 theta. So far, it's still not that bad. But here is the bad part. Here is what some people may do. You go and put 1 minus square bracket ei theta. Okay, then I just use my trigo form. So cosine negative 4 theta plus I sine negative 4 theta. Scary. 1 plus, this one is cosine, what is it? Can you tell me?
Negative 2 pi. Negative theta plus I sine negative 2 theta.
Make sure you got the bracket. Bracket negative 2 theta. Okay, then after that, you use your special identities. This one becomes a plus, this one becomes a negative sine 4 theta. This one becomes a plus, this one becomes a negative sine 2 theta. And then you get stuck. Why? Let's take a look what happens. You get what? 1 minus cosine 4 theta. Oh my goodness. Minus away sine 4 theta multiplied by I. Divide by 1 plus cosine 2 theta minus away sine 2 theta times I. Okay, so you got A plus BI and another C plus DI. How do you convert this into a, so it's a division of complex numbers, right? How do you convert this into A plus B, P plus QI? When you divide complex numbers, what do you need to do?
You need to times by the conjugate.
Yes, so horrible. You can do it. I'll leave it to you to do it on your own. I'm not gonna do it. Don't do it. I don't recommend this. The conjugate is very scary. It's A plus 1 plus cos 2 theta plus sine 2 theta, top and bottom. Then you need to multiply. Very scary. Don't do that. Here's the faster way. Famous trick. Every time you see a fraction involving e power something, you must know this famous trick already. You need to somehow involve these two special identities. Okay, and let's take a look. So here we see e power I negative 4 theta, and the bottom we see e power I negative 2 theta. If you just drop away the negative, you focus on 4 theta, you focus on 2 theta. 4 theta versus 2 theta, which is bigger? 4 theta is bigger.
Yeah.
So we focus on this fellow. We focus on the angle of this fellow. Negative 4 theta, we bring back the minus. That's why I call the angle. Maybe I'll just label it as the angle. The angle. Okay, so here the famous trick is you want to factor out e to the power of I times half of the angle. So the angle here is negative 4 theta. Half of the angle is negative 2 theta. So that means we want to factor out e to the power of I times negative 2 theta, which is exactly what the question did here. Can see?
Can.
Okay. Yeah, that's for the numerator. Oh, I realized actually the denominator is slightly different. Oh, yeah. So the trick here is just factor out half of the angle, e power I times half of the angle. So let's look at the numerator first. After you take out e power negative 2I theta, you just get e power 2I theta minus e power negative 2I theta. Can or not?
Can.
Can, because same base e, different power, what happens? You have to add the power. Minus 2I theta plus 2I theta will just give you 0. E power 0 is
1.
1, which is exactly what you have here. Okay? Are you sure it's okay? Because you lag a bit when you said 1.
Yeah.
Or is it the computer? Sure can, okay. Then let's just double check. This one, e power negative 4I theta, you take out e power negative 2I theta, it becomes a minus still remains, but it becomes e power negative 2I theta. Okay, minus 2I theta gives you minus 4I theta. Is that okay?
Yeah.
Can, okay, sorry, I think I was talking too much about the comparing minus 4 theta and minus 2 theta. You don't need to compare them, sorry. No. You just need to look within the numerator, within the denominator, separate.
Okay.
Okay, now let's look at the denominator. You got e power negative 2I theta. What's half of the angle? Half of negative 2I theta will be?
Negative I theta.
Yes, exactly. So that's exactly what you factor out. E to the power of negative I theta. Right? Half the angle. So you'll end up with e power I theta plus e power negative I theta. Is that okay?
Yes.
Confirm?
Yeah.
Okay, good. So now we can start to simplify. What do you notice? If you just recall the formula, so let me just copy it down for you. Where can I paste it? I'll just paste it as a image here. Temporarily, I'll remove it later. So we can now use the formula, right? Can now use the formula. Here we see that e power negative I theta over e power negative 2I theta divided by e power negative I theta means that they will cancel off. I will end up with e to the on the numerator. I'll end up with, if I can just reduce my font size a bit, e power negative 2I theta on the numerator, subtract away the denominator's angle negative I theta. This will simplify into e power negative I theta. Is that correct?
Yes.
Minus minus become plus. So minus 2 plus 1 gives you minus 1. Okay, good. Then now let's look at this part here. E power 2I theta minus e power negative 2I theta. Do you notice that it's really just this formula? But you replace the theta with 2 theta?
Oh, yeah.
2I theta is I times 2 theta. Negative 2I theta is I times negative 2 theta. So all you need to do now is to replace the theta with 2 theta everywhere. So you're left with 2I times sine of 2 theta. This part, numerator, okay?
Yes.
Now we look at the denominator, 2 cos theta. How to get 2 cos theta? EI theta plus e power negative I theta. Isn't it just the formula on the right side?
Yeah.
Yes, so therefore we can just immediately replace with 2 cos theta. Okay? Then we are not done yet. This one, we are just using a trick to help us to simplify. We want to convert it into Cartesian form, so A plus BI. How do we do that? Let's continue. Now you need to be very good in your trigonometric identities. Do you remember double angle identity? In particular, sine 2 theta is 2 sine times 2 times sine theta times cosine theta. Do you remember this one?
Yes.
Yes, so that's what we're going to do. Replace it with this one. But notice, once I replace it, there's a 2 sine theta over cos theta. There's a 2 cos theta at the bottom. What happens?
Can cancel out.
So maybe if I just write it out, okay, one more line. Sine 2 theta becomes times 2 sine theta cosine theta divided by 2 cos theta. Yes, they cancel off. So cosine, 2, 2. You're left with e power negative I theta times 2I times sine theta. Oh, they didn't cancel the cosine here. Okay, good. So what do we know now? What do we know now is that there is a 2I sine theta, so we leave it alone. Okay, maybe I should just cancel them off. Yeah, I'll highlight it. 2I sine theta here and here. But what about the e power negative I theta? Convert it into the trigonometric form. Cos negative theta plus I sine negative theta. Is this part clear to you?
Yes.
Okay, now, why do we want to do that? Because now you can start to see the A plus BI format. Okay, the standard trick here, when you want to go from exponential into Cartesian, right, is to go through the trigo. The trigo is like a transition. It's like if you're trying to you're on the green line and you want to go to Botanic Gardens, maybe you can take to Buona Vista, change to Circle Line. Buona Vista is like the interchange. The trigonometric form is like the interchange. You have to convert from exponential to trigo, then trigo go into Cartesian. Okay. Likewise, of course, if you go backwards, you also have to go through trigo. Okay. So now, actually, you can. This one maybe can go a bit faster. You can just find out your r, find out your theta, then you can just jump straight to exponential. Okay. So maybe going back is a bit faster.
Okay.
Yeah. Okay. Then now you sub in with cosine negative theta plus I sine negative theta. You have to remember your negative angle identities. Cosine negative theta is cosine theta. Sine negative theta is negative I sine theta. Yes?
Yes.
Then you still got 2I sine theta. Then you just have to multiply. Remember, this is one single factor multiplied together. So you have to distribute into the first two terms. So you get cosine theta times 2I sine theta, which is 2I sine theta cos theta. They swap the order, they put it on the right side. Then 2I sine theta multiplied by negative I sine theta, you get negative 2 times I square sine theta. Negative 2 times I square sine square theta. Sorry. Okay, is that okay?
Yeah.
This times this. But what's I square?
Negative square root of negative 1. Negative 1.
So which is which? I is square root negative 1. I square is?
Negative 1.
Just a negative 1. So negative 2 times negative 1? Positive 2 here.
Yeah.
Okay, that's why they drop the negative here. Positive 2 sine square. Okay, so now we got 2 sine square theta plus 2 times I times sine theta cos theta. Not good enough. We have to convert it into a 2 theta here so that we can eventually get our angles to look the same. Here is still a theta, so it's not good enough. I think so. Actually, let me think a bit. Oh, actually, no, this is perfectly fine already. Sorry. This part here is okay already. This is a perfectly fine answer. They did something a bit extra. They just convert into sine 2 theta. That's also correct. Okay, because 2 times sine theta times cosine theta is just sine of 2 theta. Okay.
Okay.
And that's your Cartesian form A plus BI. We are not done yet. We are not done yet. We are only done with Cartesian form. Now you need exponential form. How? Exponential form requires R and theta. So we just need to find R, you need to find theta. So what they did here is they let argument of this W be the theta. But instead they use this symbol. This is called phi angle. Okay, then what did they do? They found out tangent of phi first. Because eventually if you want to find an angle, it's just tangent inverse, right? But you need to take note of the quadrants. So in this case, what is the quadrant of this value of this complex number? We can double check with the angle that was given. Okay, so let's see. What we currently have is a 2 W equals to 2 sine square theta plus I sine 2 theta. What do we know about the theta? What do we know about theta?
Like
Zero, the range, exactly. So that means what I'm trying to figure out, what I'm trying to show here is that this guy is positive, this guy is also positive, which means that this is actually a complex number that's in quadrant 1. How do I do that? Let's see, using the range. If theta is in between 0 to pi over 2, here I got 2 theta, right? So I can times 2. So I get 0 less than 2 theta less than pi over, oh, sorry, it's just pi after you multiply by 2. Not done yet. Now I have to find out what is sine of 2 theta when it's in between 0 to pi. Oh, I realized something special. What do you notice about sine 2 theta, the graph? Or regardless of whether it's theta or not theta, here it will become pi over 2 and pi already. Because you times 2.
Yeah.
Yes. Is it?
Yeah.
Right? I think so. Yeah. So in that case, what is so special about sine 2 theta? We are not interested in its domain. We're interested in its range. Bigger than, it's less than what? It's bigger than what?
Is more than 0 and less than pi over 2.
Wrong. No, that is theta. That's the domain. We are interested in the range, the y value. What's the maximum y it can reach? What's the minimum y that it can reach?
1, then 1 negative 1. So it's between.
Exactly. Yes. So it actually doesn't matter what the angle is. Haha. Sine of 2 theta, it doesn't even matter. For all angles, it will always be between 1 and negative 1.
Okay.
Okay. Let me think a bit. Oh, in that case, this component here could be in the bottom as well. Because the imaginary part it could be negative, right? It could be between -1 and 0. Okay, never mind. Let's move on first. So that means we could be in quadrant 1 or quadrant 4. 1, 2, 3, 4. Let's just look at the real part first. 2 sine square theta. What is this equal? What would this be equal to? Here, let's just write this down. Sine theta, you should know that it will always be between -1 and 1 for all angles. But how about sine square? Less than 1? More than? Square already, can you still be negative?
Cannot.
It's a smaller square.
Huh?
0.
Oh.
Correct or not? And when you square a number, it's always negative times negative, positive.
Yeah.
Positive times positive, still positive. Or 0 times 0 is 0. So the smallest is actually just 0. 0 is smaller than positive numbers. Yes?
Yeah.
Yes. Then if you times 2, you have to times 2 throughout. 0 times 2 is just 0. So this is less than 2, which basically means that it's still positive.
Yeah.
So it means that you can either be in quadrant 1 or quadrant 4. Yeah. Okay.
Yeah.
Positive for the real part. That's a bit odd because we cannot restrict it to a specific quadrant. That means our angle has to be, we'll have 2 possibilities. Could be a quadrant 1 angle like this, or quadrant 2 angle like that. How to resolve this? Do we need to consider 2 possible angles? Sorry, let me think a bit.
Okay.
2 minus theta. Oh, this question has a problem. It's not that accurate. It's not that accurate to just simply say that there's only one specific angle. There's actually 2 possible angles here.
Oh.
It could be a positive one or it could be a negative one. Negative pi by 2 minus theta is also a possibility. Okay, never mind. We are gonna assume, okay? Let's assume that W, I'm gonna edit the question. I'm gonna say that argument of W is in quadrant 1, meaning that 0 less than argument of W less than, is it correct? Yeah, less than pi by 2. Okay?
Yeah.
Can let's just assume that, so we don't have to stress so much about the quadrant. Okay, forget it, not important. Just focus on quadrant 1. Okay, assume that it's quadrant 1. Okay, so that means that we can now find out our angle phi by simply taking tangent inverse, because it's just quadrant 1 angle. Tangent inverse of the opposite over adjacent. So in that case, tangent of the angle, what do you realize? It's just b over a. Correct or not? B over a.
Yeah, correct.
Into theta over 2 sine square. Then we can now try to simplify it later. Then we take tangent inverse. Here sine 2 theta is 2 sine theta cos theta numerator, and the bottom is just 2 sine square. Leave it alone. What happens? 2 cancels off, sine cancels off. You're left with cosine over sine. Can you see that?
Yeah.
What's cosine over sine? It's actually just cotangent of theta. Then this is what we call the complementary identities. I like to call the co-identities. Cotangent theta is tangent of pi by 2 minus theta. How do you prove that? Let's translate it in a right angle triangle. If this is theta, that's a right angle. What's this angle here?
180 minus 90 minus theta.
Simplify, you get 90 minus theta. Yes?
Yes.
Rewrite it in terms of radians, it's pi over 2 minus theta, correct?
Yeah.
Let's call this A, B, and C. Can you find out for me what is tangent theta? What over what?
A over C.
Tangent. Opposite over adjacent.
B over A.
Yeah, it's much better. How about cotangent of pi over 2 minus theta? What's pi over 2 minus theta? It's this angle here. Cotangent is what? Cotangent means 1 over tangent. Right?
So it's A over B.
1 over tangent of pi over 2 minus theta, which is 1 over, can you tell me what's tangent pi over 2 minus theta again?
is the pi over,
Tangent is opposite over adjacent, right?
yeah.
Opposite over adjacent.
So it's
So
A
the
over,
A over B. Yes, correct. Oh, sorry. I didn't catch that. Did you say it the first time? I didn't hear that.
yeah.
Okay. Okay, you're correct. Good. Then 1 over of A over B is what?
B over A.
A. Doesn't that look familiar?
Yeah.
They are the same. I didn't specify what's A, B, and C, so can be any length. So that means in general, this works for all angles. Cotangent of 90 minus theta is always tangent theta. More generally, you can do the same exercise and you can show that cosine of theta. Okay, you know what? I'm just gonna rewrite it in this format. Alpha plus beta equals to 90 degrees. Two angles that add up to 90 degrees. They can even be negative. Cosine alpha will be equals to sine of alpha. So sine of beta. Okay, here is co, here is no co. Likewise, you can also have cotangent of alpha equals to tangent of beta. Co, no co. Likewise, you have cosecant of alpha equals to secant of beta. Did you know these identities?
No.
This is called the complementary identities. You should know them. Basically, alpha is 90 minus beta, or beta is 90 minus alpha. They are the same. The key idea here is, provided that you have two angles that add up to 90 degrees, the co and the no co versions of each angle will be the same, will be equal. Okay, co, no co, co, no co, co, no co.
Okay.
Yeah, so that's just one of them. Then you can get tangent of pi by 2 minus theta. So if tangent of phi is tangent of pi by 2 minus theta, we conclude that phi must be pi by 2 minus theta. Can?
Okay.
Okay, good. So therefore, we have found our angle. So difficult, so painful. Finally found the angle. Not done yet, because remember, r, e, I, theta, we only found our theta. We still need our r. So that's what we're going to find now. Square root a square plus b square. Yes? A is here, b is there. Sub it in, square root a square plus b square. Can this line okay?
Can.
I'm going to zoom in. Okay, good. So here you got 2 sine square, then square. You get 2 square and sine square square, which is 4 sine power 4. Then sine 2 theta will become replaced with 2 sine theta plus times cosine theta, and then you square it. What happens after you square it? You get 2 square, sine square, cos square. Okay, let's write down one more line now. Take the square root. Anything to factor out?
The 4.
Anything else?
The sine square.
Exactly. That's what they did over here. 4 sine square. Then you're left with sine square theta plus cosine square theta. Doesn't that look familiar?
Yes, it's 1.
It's 1, right? Trigo identities. Need to memorize. It's not in the formula list in A levels. So this is just 1. So you get square root 4 sine square. It's just 2 sine theta. Okay. Then we got our r. Therefore, exponential form will just be r e I theta. You don't have to write this. Just sub in there already. You can say w equals r e I theta equals to r, which is 2 sine theta, multiplied by e to the power of I multiplied by, what's the angle again? Pi by 2 minus theta. That's the answer. Can?
Okay.
Okay, good. Okay. Yeah, and then I didn't write notes for that number 7 because I think practice questions will be more practical. Solving for z, complex coefficients and roots. Solving polynomials with all real coefficients. It is 12 p.m. I haven't had time. Okay, do you still have time?
Yeah.
Okay, I'll talk about the 4 examples that I asked you to do. Those practice questions. Before that, can we have a short 3-minute break?
Can.
Okay, we'll come back in 3.
Okay.
Mic test.
Yeah, can hear.
Okay, good. Let us return. Okay, I'm gonna go through those questions. Give me a moment to find the file first. Is complex numbers okay for you?
The easy question can.
Okay, okay. Easy question.
Yeah, easy question.
What is easy? I do not know. Okay, we'll look at it. Let me find the question first. What do you think is the most difficult topic for you?
Like application of integration
Application of integration. Okay.
and like the hypothesis testing.
Hypothesis testing. Oh no. That one should be easy. That one is like standard procedure. Must practice until
Like
you get.
find the Z, that one I don't know how to do.
Yes, that is a standard procedure.
Okay, I read.
Okay. It's all right. I'll go through it. Eventually, I'll go through it. Yeah. Okay, let's begin. We'll talk about question 3. Do you have the question paper?
Yeah, I open on my phone.
Okay, can. Yes, that'll be good. That would be good. Oh, I need to edit this. Resume. Okay. Can I just change it? Oh, change it to presentation mode. Okay, Ken. So yeah, bigger screen. We're gonna go through the complex. This is what is the title I gave it? Number 1 complex numbers. Okay. I'll send you more files later.
Okay.
So let's go through this first question. Question 3. Okay, go to question 3. Let's take a look at the question. Some of these questions are actually A-level questions, so expect them to come out. Okay, question 3, you got x plus yi bracket squared equals to -5 plus 12i, where x and y are real numbers. Find the possible values of x plus yi. Hence, solve the equation z squared plus 4z equals to -9 plus 12i. So actually, this question, they could have rephrased it. Start you off by z squared equal -5 plus 12i, then solve for z. They could have just said that, but they were kinder to you. They gave you a hint. Z you can replace with x plus yi. Okay, that's one of possible ways to do this question. Then how do you continue? You just need to expand the left hand side. So a square plus 2ab plus b square, right? Simplifying, yi square is y square I square. I square is -1, so you can just minus away y square. Is this part okay?
Yeah, okay.
If you're even faster, just combine all the like terms together. All the real terms together and the imaginary terms separately. So you got the real and the imaginary equals -5 plus 12i. Then there's something called comparing the real and imaginary parts. Do you know this?
Yeah.
Okay, so very simple. You just get parts. Sorry. You just have to say x squared minus y squared is the real part, so it's equal to -5. And 2xy, the number in front of the I, they will be equal to each other. So which one do you think is simpler? You can ignore the rest of it. Which one do you think is simpler to work with? The left one or the right one?
The right one.
The right one looks simpler, right? Here got square, you need to take a square root. So here, maybe I can divide by 2 on both sides. I get 12 over 2 is 6. Maybe I can now make y the subject. What will I get? 6 over x, correct?
Yeah.
Okay, I'll call this equation 1, call this equation 2. Then I'll say sub 1 into 2. what do I get? X square minus bracket square equals -5. What's y? 6 over x. Square both sides, what do I get? So far, so clear? I
Yeah.
mean,
Can.
can okay, continue. Then I'll go faster a bit. 6 square minus 36 over x square equals to -5. How do you get rid of that fraction? I can multiply both sides by x square. So times x square times x square. Right hand side becomes -5x square. X square times x square, get x power 4 minus away 36. How do we solve this? We can bring the 5x square over. So x power 4 plus 5x square minus 36. Do you realize that this is just a quadratic equation?
Yeah, but like x is x squared.
So we can say let capital X equal to x squared. So that means we'll have x squared plus 5x minus 36. Notice that I'm using curvy x versus straight x. They are different. Then solving, I will be able to get what? Let's type in the calculator. Okay, to be honest, actually, I don't need to do this because I have a GC, so I can just manually solve a power 4 equation. Correct or not?
Can.
Then therefore x squared equal to 4, x squared equals -9. So x equals to plus minus 2, x equals to, here in this case, is it plus minus 3?
Yes.
Wrong.
Oh.
Because there is a negative, remember? X squared, can you have negative?
Cannot.
You can only when it is when it is complex. But in this case, x is what?
Real.
They told us x, y are real. So that means that in this case, x will actually be plus minus square root of -9, which is plus minus square root 9 square root -1, which is plus minus 3i. But this one you have to reject both of them because x is real number. Okay, so that means we're only left with x equal -2 or x equals to 2. Can? Are we done?
No.
No, we still need to solve for y, right? So how do we solve for y? We have to go back to this equation 1. So you have to consider two cases. Sub x equals -2, sub x equals to +2. What will we get? Y equals to 6 over -2, -3. Y equals to 6 over +2, +3. So altogether, this is a curly brace. We usually represent our final answer like this, a curly brace, and then we write down x equals, y equals, to show that they are one pair of answers. In this case, it's x equals -2, y equals -3, and x equals 2, y equals 3. Can?
Oh.
Yeah.
Oh, okay.
That's one way.
Like that.
Yeah, present it this way. It will be nicer.
Can.
Yeah, that's one way to solve it. Okay, hence solve z squared plus 4z equals -9 plus 12y. This is next part. This is the hence part.
So z is x plus yi.
Here you have to be a bit smarter about it. You should, because this is a hence question, you need to make use of the fact that x plus yi squared equals to -5 plus 12i. So what do you notice about the right-hand side of that original equation compared to the current equation? Do they look the same?
The 12i is the same.
So almost the same. But here, -9. Can you rewrite it as -5 plus something? How about -4? Does that work?
Yes.
Yes, right? Okay, that's the trick to this question. You must see that you can rewrite it as -5 plus 12i. Okay? So that's what we're going to do. And then after that, the -5 plus 12i, of course, you can substitute. You can, sorry, not substitute. I'll talk about it after I do it, the thing. So the trick here is you want to split it up into -4 minus 5 plus 12i so that we can get something similar to the right-hand side of the original equation. Then what do you do with this -4? Throw away to the other side, because we want the right-hand side on its own to look like the original equation, the right-hand side. So we'll throw the -4 to the other side. We'll be left with z squared plus 4z add on of 4. Oops, sorry. I should start a new line. Maybe I'll just copy this down to be neater. So far, okay?
Yes.
Okay, I need to start a new page. Not enough space. The hence part. This is still question 3. Yeah, so now what do you notice? This one, do you realize that you can complete the square? Isn't this just z plus 2 square?
Yes.
Correct or not?
Yeah.
Let me just double confirm. Yeah, correct. Yes. Luckily, when you try to complete the square, there's a -4, which cancels off with the +4. So it's really just a perfect square lah. Can? Okay?
Can.
Okay, good. So that means that, doesn't this look familiar? Something power 2 equals -5 plus 12 5.
Yes.
Isn't that what we were trying to solve just now?
Yeah.
Something power 2 equals -5 plus 12 5. The original question was actually asking x plus yi power 2 equals -5 plus 12 5. And minus x plus yi is really just a complex number. Here, z plus 2 is also just a complex number. So what can we deduce? Using the previous result, we can deduce that z plus 2 must be what? Look at the solution we had just now for x and y. So that means that over here we will have a -2 minus 3i as one of the square roots of -5 plus 12i. Do you realize that we were actually just taking a square root?
Yes.
X plus yi squared is -5 plus 12i. So it really just means that x plus yi is just the plus minus square root of -5 plus 12i. So the alternate solution to this was just to use a GC. Oh, just use a GC, then you can get the answer. Should I show you? Do you want me to show you?
Can.
Okay, let's go. Okay, I need to turn on my. Okay, and then I need to go here. Hold on a second. Window projector, share screen. Can see?
Yeah.
Okay, good. So just clear a page first. Okay, yeah, so you need to take the square root, right? So second square root here. What are we trying to take the square root of? -5 plus 12i. So negative must make sure you put a negative sign. 5 plus 1, 2i. Second i. Enter. Ta-da! You get the answer straight away. No working involved.
Oh, but I can just copy from the GC.
Can, actually. Yeah, because the question never said show all working out. So it's fine. Yeah. Okay, 2 plus 3i is one of those answers. Yeah, okay. Change back. Okay. Yeah, so 2 plus 3i is one of those answers over here. Then that means you have the negative version because of plus minus, right? Then you get a -2 minus 3i. Okay, so that means we have found the two square roots of -5 plus 12i. We can use that answer in our hence question. So z plus 2 and z plus 2 can have two possible answers. They will just be the two square roots. The two possibilities for the square roots, like this. Is this okay?
Yeah.
Okay, then you just solve for z. -2, you get -4 minus 3i. Same thing, -2, you get 3i. That's it. That's all. Solved. Is this clear?
Yes.
Okay, good. That's question 3. Let's move on to the next one. Question, what did I want you to do? Question 9. Okay, let's take a look. This is a 2013 paper. Question 9. Complex number W is given by 1 plus 2i. Am I still connected? Can you hear me?
Can.
Okay, good. W equals 1 plus 2i. So what you want to find is W cube. Okay, you want to find W cube in the form of x plus iy. So this one, no choice. You just have to manually expand. Do you remember Pascal's triangle?
Huh? No.
3 choose 0, 3 choose 1, 3 choose 2. Binomial expansion.
No.
Huh? Really?
I didn't even know about this thing.
It's Amex.
Oh.
Wait, you forgot already?
Yes.
Yeah,
I got used it.
Huh? Sorry?
I don't think I used the triangle.
Yeah, the triangle is not needed lah. The triangle is just for convenience. Like 1 plus 2 gives you 3, 2 plus 1 gives you 3. Of course, you can use 3 choose 0. But do you know how to do binomial expansion?
Can I use the MF26 the formula?
Wait, sorry, I forgot. Let me check. MF26, do they provide a binomial expansion formula? Let me just double check first. Hold on a second. Yes. Okay, that's a McLaurin. Yes, correct. It's the formula. Always provided. Okay. Yeah, it's from Amex. So yeah. Yes, you can use that. Yes. But do you know this? So this is basically the expansion.
Yeah.
Can then I'm just gonna use it. So yeah, then we are going to immediately get 1 plus 2i power 3 plus 3 times 1. Sorry, that's not correct. Oh my goodness. Let me try again. 1 cube plus 3 times 1 power 2 times 2i power 1. Maybe if I really want to follow the formula, it would be three choose 0, then 3 choose 1, plus 3 choose 2 times 1 power. You notice the pattern, 3, 2, then 1. Right?
Yeah.
Then times 2i power 0, 1, and tell me. Mike test, can you hear me?
The next one.
Yes, correct.
The 3 choose 3.
Oh, no. Here. Missing power. What power? 0, 1,
2.
2. Very good. Okay, can. Then the last one is not enough space. Let me bring it down. Last one will be, no space. How do I manage my space? Yes. Can you try the last one?
3 choose 3. Then I 0, then 2 I 3.
Oh, it's not I, it's a 1, by the way. I'm just taking the first term, 1. This one binomial expansion from secondary school Amex. Oh.
Okay.
And so I power 3. What's the pattern here? 3 plus 0 is?
3.
2 plus 1 is?
3.
1 plus 2 is?
3.
0 plus 3 is?
3.
That's the pattern. No? What other patterns are there? Power 3, then the top number stays the same. Then the bottom number, increase.
Yeah.
Increase. Okay. Yeah. All right. And also there's a increasing pattern here as well. 0, 1, 2, 3. The other guy is decreasing. 3, 2, 1, 0. Can see a pattern?
Can.
Okay, just more simply, it's really just 1 times anything power 0 is just 1, right? So you can just ignore it. So it's just 1 cube, 1 times 1 cube. Then next one, if you know the binomial coefficients here, it's really just 1, 3, 3, 1. So instead of writing so many things, you can just write down 1331 straight away.
Oh, okay.
Yeah, it's faster. So you can just write down 3 times 1 power 2. Of course, if you're fast enough, you can also realize that 1 power anything is just 1. So you can skip it. Then it's just 2i power 1 plus 3 again times 1 power 1, which is, you can skip it. Then 2i power 2 plus 1 times 1 power 0 is just 1, then 2i power 3. Is this clear?
Yes.
By the way, the power 0 here, I replace for 1. Can now?
Can.
Okay, good. Simplifying, we get 1 plus 3 times 2i is 6i. 3 times 2i squared. This one is 4i squared, which is -4. -4 times 3 is -12. Then 2i cube is 2 cube I cube. 2 cube is 8. I cube is -i. Times a 1, then you get -8i. Is this correct?
Yes.
Can Okay, good. Then now you simplify. You get 1 minus 12, -11, plus 6 minus 8, which is -2i. Actually, there was a faster way. What's a faster way? 1 plus 2i power 3. Do you have your GC with you?
No, I can take it.
Yes, go take it.
Okay.
Okay, then you key in bracket 1 plus 2i close bracket power 3.
-11 minus 2i.
Very good. Okay, so manual expansion works. But here, I think actually the question only requires you to use a GC to expand it. Oh, but no, actually they said show your working.
Yeah.
So no choice, binomial expansion, you need to show the working.
Okay.
Okay, part 1 done, move on. Part 2, let's take a look. Given that W is a root of the equation, blah, 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 find the values of the real numbers A and B. Let me just go back to the summary notes and take a screenshot of the, what do you call this? Essentially the summary here. Just like this. Is it very small? I hope you can see.
Can see.
Yeah, a bit small. Okay, so basically we are now currently in which case? Number 1 or number 2? Complex coefficient or real coefficient?
Complex.
Wrong. We're in the second case, real coefficient. Do you know what's a coefficient?
The number before the
Variable, in this case, z. So z is complex, yes, but look at the numbers. I copy the equation first. A, z cubed plus 5, z squared plus 17, z plus b equals 0. A, 5, 17, b, they are all what kind of numbers?
real.
Real numbers. They told you A and B are real. So 5 and 17 also obviously real. Don't have the I. So we are in the second case, okay? We're in the second case. Are you clear on that?
Yeah.
Roadmap, here is case number 1, case number 2. We are not in case 1, we're in case 2. Clear? Okay, what did I tell you about this? Number 1, you need to use the fundamental theorem of algebra. If z is a root, then z star, the complex conjugate, is also a root. So what does it mean? They told you that W is a root. Since blank, 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 therefore W star is also a root. Can you tell me what is the blank, blank, blank?
Since the coefficients are real.
Very good. That's the key idea you must remember. Coefficients are real. That is necessary. Even if at least one of them is not real, you cannot quote this rule anymore. Are we clear on that?
Yes.
W is a root, W star is also a root. So what do we know about W? W is 1 plus 2i, correct?
Yes.
W star is?
1 minus 2i.
Very good. So if you know these are the two factors, right? Then there's a few ways that you can go about solving this equation already. You can either, okay, method one, I'll show you method one, is to take this one, you substitute into the z everywhere, you get an equation, then you rewrite it as a p plus qi, where p and q are in terms of a and b. Then it's equal to 0, which is 0 plus 0i. Then you can now compare coefficients. Sorry, not compare coefficient. Sorry, should be compare real and imaginary part, and then you solve for a and b. The alternative is to use factor theorem. Okay, I'll just show you both ways. This one is called sub. The method 2 will be to use factor theorem. Maybe I should elaborate a bit more. Sub, then compare RE and IM. RE and IM means real and imaginary parts. This is MTD number 2. Okay, I'll do method 2 later. No space. Remind me to do method 2. Okay, so let's do method 1 first. So since we know that W is a root, right, we can just substitute in directly, and this will still into the Z, and we will still get equals to 0 on the right. So what we get, a times 1 plus 2i power 3 plus 5 times 1 plus 2i power 2 plus 17 times 1 plus 2i plus b equals to 0. Clear so far?
Yes.
Okay, now we expand. What's 1 plus 2i cubed? We already expanded it just now. It's negative 11 minus 2i. Actually here, because it's already, they didn't say show you're working, you can just use a calculator. Can you type in for me 1 plus 2i square? And then you times 5 as well. In fact, I'll just type this whole thing in. You know what? Just type this whole thing in. It doesn't involve A, it doesn't involve B. You can just type the entire thing in. Tell me what you get.
Uh, 2 plus 54i.
Good, same answer as me. Then plus B equal to 0. Okay, then we can now start to simplify a bit more. Negative 11a minus 2ai plus 2 plus 54i plus b equals 0. Collect like terms. This is a real part. This is a real part. This is a real part. Combined, you get negative 11a plus 2 plus b. That's the real part plus I times of the imaginary part, which is, can you tell me what is it?
The negative 2a plus 54.
Yes, equals to 0. But what's so special about 0? 0 is nothing but 0 plus 0i. So now you can compare real and imaginary. What do you get?
Like both are 0, the negative 11.
So tell me the two equations.
Negative 11a plus 2 plus b equals to 0.
And
Then, negative 2a plus 54 equals to 0.
very good. Which one do you think we should solve first? Left or right?
The negative 2a plus 54.
Exactly, because there's only a single variable. So 2a equals 54, a equals 27. Are we done? No, still need to solve for b. So sub a equals 27, negative 11 times 27, plus 2 plus b. b equals to minus 2 plus 11 times 27. I need a calculator for this. 295. Can? Okay, 295. Can Okay, good. Method 1 done. Not done yet. Now we are gonna try method 2. Let's copy down the equation. Okay, let's just write down some of the starting working over here. Since we know that W is a root, W square is also a root. 1 plus 2i and 1 minus 2i are roots. That means that I can factorize. So I can say let f of z, the variable is z, that's why I put z. Okay, it's not always x, it can be z, it can be other variables. Be this fella here. Sorry, you had a question?
No.
Okay, good. That's f of z. So since we know that, oh yeah, another way that you can say that it's a root, right, is to say that f of w star equals 0 and f of w equals 0. Or in other words, 1 plus 2y, 1 minus 2y. Okay, some questions, they may test you on your factor theorem. Again, it's a O-level A-max topic. They will say f of 1 plus 2y equals to 0. Sorry, my equal sign. F of 1 plus 2y equals 0. Then you're supposed to know that, oh, that means that 1 plus 2y is or rather z minus bracket 1 plus 2y close bracket is a factor. Does it make sense?
Yeah.
This means that z minus away the w star, which is 1 minus 2y, and z minus bracket 1 plus 2y are factors of f of z. Clear so far?
Yeah.
Okay, now I'm gonna move this down. This is question 9, right? Okay. Then if we know that they are factors and we know that this one is power 3, so that means we can factorize it using factor theorem. Okay, remember I go back to the procedure here. Step 2, fundamental theorem and then factor theorem. Deduce the factored form of the polynomial, then you expand, then you compare coefficients. This one is compare coefficient, not comparing real and imaginary, but this is how I'm going through this procedure now. Okay, maybe I should have included one more, the sub x oh wait. Here, let z equal to a plus bi. I should also bring it down here. You can also do the same procedure, sub z equal to a plus bi, and compare real and imaginary. This method actually applies to both cases.
Oh, okay.
Yeah, because it applies to both cases. Okay, but anyways, we just use the factor theorem first. So factorize it first. First factor is the z minus 1 minus 2y. Second factor is the z minus 1 plus 2y. Then what's the remaining factor? Here is power 1, here is power 1. Z power 1, z power 1. Here is z power 3. How much more do we need? How much more power do we need?
1.
1, exactly. 1 plus 1 plus 1. If this was z power 4, then how much
Then
more will we need? Z square, right? Then in general, if that was z power 4, then it will be az square plus b. Oh, I shouldn't use the a and z. I should use a different letter. Say pz square plus qz. What's after q? R. Okay. I need to write it in this general form. But of course, in this case, it's not power 4, it's power 3. So we only need pz plus q. Okay? Can, good. So that means that now we need to figure out what is p, figure out what is q. But before that, let's just simplify this part here. Z square. Okay, I'm gonna treat this as one lump. And then I multiply. So z times z, I get z squared. Z times negative of whatever, I'll just simplify that as negative. No, I'm not simplifying, I'm just multiplying first. And then the other one will be minus 1 minus 2i times z. And then last one will be negative times negative gives you positive. 1 minus 2i times 1 plus 2i. Square bracket times pz plus q. Collect like terms, z square leave alone. This one, there's a minus z times 1 plus 2i minus 1 plus 2i. Do you get this part?
Yes.
I changed sign now because of the negative.
Yeah.
Oh, sorry, that's wrong. I already factor out a negative here.
Oh, okay.
Sorry. No. Sorry, this should be still 1 minus 2i. Okay. Plus 1 minus 2i. Then plus this one, a minus b times a plus b. So it's a square minus b square. Times pz plus q. So far, okay?
Yes.
Okay, then continue. Z squared minus z. This one, 2i and minus 2i cancel off. 1 plus 1 is 2. So I'm actually just left with minus 2z. Okay?
Yeah.
Plus 1 minus 2i squared is what? 2 square I squared, which is 4 times I squared. I squared is?
-1.
So negative 4. So minus a negative 4, okay? Which
Yeah.
means that you simplify it into 1 plus 4, which is 5. So I'm just going to clean up a little bit. Plus 5. Then you multiply by PZ plus Q, okay?
Yeah.
Okay, good. Just combine them all together. Okay, good. Then now you want to compare it with the original AZ cube plus P 5Z squared plus 17Z. Do you know how to compare that already, or do you want me to expand it and into something x cube, something cube, something Z squared, something Z and constant?
Compare directly.
Directly compare. Okay, so here is how you do it. If you do it directly, okay, due to space constraint, I'm going to copy down the equation at the side. Here's how you do it. This is f of z in the factored form. Here is f of z in the original form. I will first start with looking at the constant. So here is the constant plus b. How do I get constants? Only one way. Constant times constant. So that means that 5q is compare. CF means CONFER. It's Latin for confer. Confer means compare. Because I'm lazy to spell out. Okay, so I write CF. CF coefficient. What coefficient? This one is the coefficient of the constant. So 5q equal to b, right?
Yes.
Okay, that doesn't help much. Let's compare the next one, which is the quadratic. Sorry, the cubic. So that would be z squared times pz. I got az cubed. So what does it mean?
The z squared minus 2p is a.
Z squared minus 2p? Minus?
Like
Why minus?
1 minus 2p is 5.
Oh, you're going a bit faster already. Yes, you're looking at the z square already. Okay, let's just do it step by step. Z squared times pz, we will get a we'll just get a p equals to pz cubed times a equals to az cubed, so p equals to a. Then maybe I think is safer and better for you if we do it step by step. Here is constant, here is z cubed. This one would be z squared. Let's take a look. Z squared. Later I'll show you how to do it with a fully expanded form. I think it will be safer for you. So let's see, how can we get z squared? Can do z squared times q and minus 2z times pz. Which means that what's the coefficient? 1z squared times q plus minus 2z times pz. Don't need the z, just the coefficients will do. Equals to what? 5. So q minus 2p equals to 5. Is this part okay?
Yeah.
Okay, then let's look at the linear term now. Z. Anything that we can deduce? How do we get linear term?
The 5 times pz or the negative 2z times q.
Correct. Yes. Good. Okay. Can. Correct. Okay. Purple color highlight. It means that you get negative 2p. Sorry. Negative 2z times q. So negative 2qz and 5 times pz, which is plus 5p. That's equal to what? That's the coefficient of z, which is 17. Yes?
Yes.
Good. Then we now have our enough equations to solve already. We need this guy and we need this guy. Let's just clean this up. You get, actually, it's already cleaned up already. Q on the left, Q on the left. P on the right, P on the right. Use your GC or use scientific calculator. What do you get? You know how to solve on a GC?
Or yeah.
Okay, type it in. Go.
Q is 59. Then Y is
Good.
27.
Good. Okay, can. Then now we can answer the question, what is A, what is B? 5 times Q, so 5 times 59. And of course, for A, it will be equals to P, which is 27. What's 5 times 59? Is it 295?
Yes.
Okay, good. So we solve for A and B, two different ways already. Can check
Okay.
the answer. I think it's the same. A equal 27, B equal 295. Can?
Can.
Okay, good. That is method 2. But we are not done yet, actually. Because here, the next part, they ask us to find, using these values of A and B, find all the roots of this equation in exact form. Okay, so maybe I'll just continue with method 1 at the side, and then I write down my question 9 part 3. So now that I know, okay, in my method 1, I didn't use the complex conjugate theorem thing. I didn't use this. So I didn't know that 1 minus 2i is a root. So I only know that I have my A and B. So actually in this question, since we already know the A and B, so that means that the equation simplifies into 27z cubed plus 5z squared plus 17z plus b, in this case 295, equals to 0. This is just a cubic equation, so actually you can just use GC. Okay?
Okay.
Yeah, then you can solve. Let me just check what's the answer first. Yeah, so therefore you will just get 1 plus 2i, 1 minus 2i, z equals, or z equals negative 59 over 27. Okay, using a GC. I'll leave that to you. But let me show you another way to do it by manually, what do you call it? Manually solving it. Okay.
Okay.
Here's the manual way. Manual way is to figure out what is your P and Q. Then you factor it like this. So what is my P? What's my Q? 27 and 50. Here, right? Here. Yes. Okay, so I can now copy down this expression. F of z. Okay, if you recall, this is the form of f of z. Let me remove the highlight. So you can replace the P and Q, right?
Yeah.
Okay, so let's do that. So P is 27, Q is 59. Okay, then we are actually trying to solve this equal to 0. How to solve? Now that you have something multiplied by something equals to 0. Conclusion is each factor must be equal to 0. So first guy equals to 0, z squared minus 2z plus 5 equals to 0, or 27z plus 59 equals to 0. This one, first you solve it, you get negative 59 over 27. The next one, you try to solve how? You need to use
Like like
don't need quadratic formula can already. I'll just use a GC. Negative b plus minus. Here I show you how to do it manually.
Okay.
Oops, sorry, minus. Yeah, type in the calculator. I think you'll get your answer. I'll leave that to you. Okay. Or do you want me to show you how to simplify?
Don't need.
Don't need. Okay. Sorry. Okay, that is question 9 part 3. This is question 9 part 3. Okay. The manual style. Manually do it instead of using a calculator. Okay, next question. I want to finish 4 questions. This is taking so long. Okay, question 13. Let's go. Question 13. Let's go. Oh, by the way, your homework will be the rest of the questions in this worksheet.
Okay.
In the tutorial. Just do all. Okay, question 13. Do not use a calculator in answering this question. You have part 1. The complex number z is given by z equals to 1 plus IC. Okay, so the real part is 1. Imaginary part is? What is it? Can you tell me?
C.
Is C. Okay, good. C is an element of real numbers. And C is not equal to 0. Find z cubed in the form of x plus iy. Do you want to try? I mean, just tell me what to write. I write for you.
Oh, the 1 plus IC cube. So I need to I don't have the MF.
Sorry?
I don't have
Just Google. Just Google. Open a browser, then type MF26. MF26.
1 cube plus 3 choose 1, then 1 2 1 to
Power
power
2.
then the IC, then 3 choose 2, then
Plus 3 choose 2.
then A square.
A square?
A1 then
1.
IC
Power 1. I see.
square.
Good. Check. 1 plus 2, is it 3? 2 plus 1, is it 3? 3 plus a 0, is it 3? Yes, yes, yes. Then you're on the right track. Next, last one.
The 3 choose 3, then is the IC cube.
Good. Perfect. Simplify. 1, 3 choose 1 is 3, times 1 is 1 square is 1 times IC. Plus 3 choose 2. 3 times 2 over 2 factorial. Of course, that's what the formula give you, but you could have just typed in the calculator straight away. What's 3 choose 2? It's really just 3. Okay, times 1 is just 1. And IC square is?
Negative C square.
Very good. Negative C square times 3. So simplify, I can get a negative straight away in front of the 3. Negative 3C square. Can?
Yeah, can.
Can, good. Next one. We're going to have 3 choose 3, which is just a 1 multiplied by IC cube. What is it?
Negative square root negative 1 I. Wait.
Remember, I square equal negative 1.
Negative I.
Negative I, yes. Because I cube can be written as I times I square, so I times negative 1. Negative IC cube. Okay? Can, maybe I should. Yeah, I should have done this at the start. Okay, then 1 times IC cube will become 1 times negative IC cube. So it just simplifies into minus away IC cube. Okay, that's good. We now have to, it's better to combine all the real together, all the imaginary together. So real, you get 1 minus 3C squared plus I times 3C minus C cube. Is this okay?
Yeah.
Okay, very good. Let's move on. This is the x plus iy formula. Oh, x plus iy. That's my x. That's my y, as requested by the question. Part 2. Given that z cube is real, find the possible values of z. What does it mean when they say it's real?
Like
There's
it's also the root.
it's implied to be purely real. Sorry, can you say again?
The conjugate is also a root.
No, wrong. Let me think a bit. No, wrong. No. Conjugate is also a root. You don't just memorize real, then conjugate is a root. There's more context to it.
Oh.
Conjugate is a root. When we say root, it's root of an equation, polynomial equation. It's when you have a, let me increase the font size, polynomial equation whose coefficients equal to 0. Okay, let me write it neatly. Equals to 0. Maybe I should write it more explicitly as f of z equals to 0, where coefficients of f of z are all real. Coefficients of a polynomial equation f of z equal to 0 are all real. Then sorry, still need one more information. And z is a root of f of z equals to 0. Then finally you conclude that z star conjugate is also a root of f of z equals to 0. Okay, that's the full sentence. You don't just memorize real means conjugate is a root. No. Here, when we say z cube is real, there's no equation. Right? There's no z cube equal to 0. There's also no polynomial. Polynomial equation means something like we've seen just now. Az cube plus 10z squared. I can't remember the numbers already. 999z minus 7 equals to 0. Something like this. Right? Real. Maybe I shouldn't put a A, I should put a 8. Only when equals to 0, then that's the only case where we talk about the conjugate. Here, we are looking at z cube. They tell you it's real. What you need to understand is that z cube is just this value here, x plus iy. X plus iy. What does it mean when they say it's real? It means it's purely real. So what do you know about the imaginary part?
Is 0.
Very good. This implies that the imaginary part of z cube equals 0, which implies that 3c minus c cube, right? That's the imaginary part, equals to 0. Is that clear?
Yes.
Can okay, how to solve for c? How to solve for c? Use GC. You see that this is really just a cubic equation. Minus c cube plus 0c squared plus 3c plus 0 equals 0.
Yes.
Use a GC. Of course, I think that's a bit slow, so I'm just going to factor out c3 minus c squared. Okay. You can go and type it in, and can you help me to type this in while I solve it manually? Then you see if the answer is correct.
Okay.
Okay, then therefore c equal to 0 or 3 minus c squared equal to 0. So c squared equal to 3, c equal plus minus square root 3.
Oh, yeah, correct.
Correct. Okay, good. So what did the question actually ask? I can't remember. Let me see. Given that z cube is real, find the possible values of z. So if you stop here, you're not answering the question. You want to answer the question. What did they say? They want the possible values of z. What is z? Z is x plus iy.
Yeah.
Or actually, what is x and what is y? We found out already just now. X here, y here. So, wait, let me read again. Sorry, wrong. No. Wrong. This is not z. What is this actually?
Huh?
1 minus 3c squared plus I times 3c minus c cube is actually equals to?
Z cube.
So sorry, I was confusing you. No, it's not. We are not looking at z cube. We're supposed to look at the original z.
Oh.
This guy. Yeah, don't look at this. Focus on this. 1 plus IC. Okay, 1 plus IC. So yeah, 1 plus IC, 1 plus IC. Sorry. 1 plus IC. So that means that Z equals to 1 plus 0 times I, which is just 1, or Z equals to 1 plus IC. The other one would be negative square root 3I. Simplify, you get 1 minus root 3I. And of course, the last one will be Z equals to 1 plus root 3I. Can you just replace with the 3 possible values of C? Is that okay?
Yeah.
Can yeah, then that's your answer. 3 answers. Okay, that's part 2 done. Let's move on to part 3. For the value of Z found in part 2, for which C is less than 0. So look at the answers. Which one is C less than 0?
The 1 minus 3.
No. Oh. Yeah, correct. Yes, this guy. So they say that using this value of Z found, find the smallest positive integer n such that Z power n, where Z is 1 minus square root 3I. This Z, we're using this Z only. Power n, then you take the modulus, is more than 1000. Later, you want to state the modulus and argument of Z power n when n takes on that value. Okay, so that's when your modulus properties will apply. Must know the modulus properties. Okay, I'm going to start a new page. This is question 13, part 3. What do I want to say? Yes. For C less than 0, the Z of interest to this question is Z equals 1 minus square root 3I. I'm just writing this down to remind myself, because I'm very forgetful. Z equals 1 minus square root 3I, not 1 plus root 3I. Can?
Yeah. Can.
Okay, using this value of Z, what they want? They want Z power n. They want modulus Z power n to be more than 1000. So let's try and figure out what is modulus of Z power n. So let's see, modulus of Z power n. Do you remember an identity you can use?
The plus minus.
Modulus of Z power n. Let me show you again. Oops, sorry, only 3. Which one?
Oh, the
1, 2, 3.
one.
Third one. What happens when you have a power inside the modulus?
And move it out.
Move it outside, exactly. So here, that's what we're going to do. Mod Z, move it out. Clear so far?
Yeah.
What is modulus Z? Square root
Square
and power
root
n.
1 square plus the square root 3 squared.
Negative square root 3 or positive. Oh, okay. Then square root 3 square cancel off, you're left with 3. Plus 1 square is just 1, then square root, then power n. 1 plus 3 is 4, square root 4 is 2, 2 power n. Clear so far? Okay, so what the question is really asking you to do is find the smallest positive integer n such that 2 power n is more than 1000. How do you do that? Let me show you how to do it on your GC. Let me wait a minute. Is it sharing? Can see?
Can.
Okay, good. So yeah, how do you do that on a GC? What you do is you go to y, because remove this, 2 to the power of x. Can? Don't press graph, press second first. Then you click here, it will activate the blue color buttons, which is table. What do you see? X equals 107, y1 equals 1.6, e power 32. E32 means that it's 1.6 times 10 to the power of 32. Very, very big number.
Yeah.
So what the question want? They want to find the smallest value of n such that 2 power x, or in 2 power n, or in this case our x, takes on a value that's more than 1000. So it's probably a lot smaller. So here I notice that my table of values starts at a very big number. So how I can change it is I can press second table set. Then table start here is 107, right? I can start with something smaller. Let's say just 10 is good enough. Okay, 10. Second, then table set here. And then I change to 10. Then now I go back to second quit first. Okay. Second table. Okay, then you need to scroll up and scroll down a little bit. Until you see this is these x values are really just the n values. When n is 6, 2 power 6 is 64. When n is 7, 2 power 7, 128. So on and so forth. When n is 8, 2 power 8 is 256. N is 9, 2 power n is 512. N is 10, 2 power n is 1024. N is 11, 2 power n is 2048. So what is the smallest positive integer value? So that 2 power n more than 1000.
10.
Exactly, it's 10. 9 is too small, 512. 10 is just nice, it's bigger than 1000. So the answer is 10. No? Understand? No?
Yeah.
Yeah, just use the GC, second table. Okay, type the y equals here, then second table. If your value is too small, just guess and check. Just change the start value. Need to do guess and check. Okay. Okay, change screen. Wait a minute. Okay. Then you just say using GC n equals 10. And that's it. Done. Okay. So you just need to know how to use GC. Not done yet. Okay. We still got modulus and argument of z power n when n takes on this value. Okay, let's take a look. So modulus of z, so it's really just n power 10, right? So modulus of z power 10 is what? Just mod z power 10, right?
Yeah.
Mod z power 10. So what's mod z? We already figured out it's really just this. It's really just 2, right? Modulus z is just 2. Or rather 1 plus square root 3 square root, which is just 2. Okay, so it's just 2 power 10. That's the answer. If you want, you can write it out in full.
Okay.
I'm not gonna do that. You can write it out. Okay, I'll write it out. It's not that big. 1024. Okay. Can what else? You now want to find argument of z power n. In this case, is power 10. So what is this equal to? When you have a power, look back at the table of identities. You should memorize this. You have to memorize this. The properties, magnitude. Which one can we use?
The fourth one.
Fourth one, what does it say?
Like can put it in front.
Yes, correct. So it's basically like the logarithms. Just remember, argument is like logarithms. You already memorized logarithms. You should be able to easily memorize argument, the identities. So just bring down in front. You can look at the rest on your own. The 10 times argument z. What is argument of z? Recall that the z that we're using, I forget already. Very forgetful. So I look back. Oh, wow. I write down an explicit sentence here to remind myself. The z of interest in this question is z equals 1 minus square root 3i. Is it z equals to 1? Is it z equals 1 plus root 3i? No. Only this one. Okay. Because I very blur, so I need to make sure I write down something like this so I can remind myself. Okay, bring it down. Then what did I want to find again? Argument of z. How to find argument of z? Just now I haven't found.
Tangent inverse.
Wrong. Here's a step-by-step procedure for you. Step 1, draw. 1 minus root 3 over here. Okay. Step 2, label angle. Do you turn anti-clockwise to reach the line? or would you turn clockwise?
Clockwise.
Clockwise, and it must always be starting from the positive real axis. Sorry, I forgot to put down RE and IM. Okay, that's your theta. Then how? Tangent inverse.
Then negative tangent inverse.
Negative
3/1.
root 3. Sorry, my handwriting. Root 3/1, right?
Yeah.
Good. Yes. Then therefore this is the, and I actually can't remember this. This, oh, this is 60 degrees. Yes. So it's pi by 3, right? Negative pi by 3.
Yes.
Okay. So you are required to know your exact values. Do you remember your triangles?
No.
Two equilateral triangle. This is a perpendicular bisector. So 1, 1. 90 degrees over here. Pythagoras theorem. This is a right angled triangle. What's the length here?
2 square minus 1 square.
Which is, not done. You still need to take out.
Modulus.
No, 2 square minus 1 square.
Oh,
And square root. Square root 3, Can, Okay, good. This is equilateral triangle 2, 2, 2. Right? So what's the angle here?
45.
Equilateral triangle, all 3 angles equal. Something plus something plus something. X plus X plus X gives you 180. So what's one of the angles?
60.
Yes.
And
of course,
why got 90 degrees there?
it's a perpendicular bisector.
Oh, okay.
Perpendicular bisector that splits equilateral triangle in half. Split in half like a stingray. Split half. Okay, then in the other angle on top is 30 degrees. Yes?
Yeah.
90 plus 60 plus 30 is 180. Okay, then this is the triangle you should already know and be very familiar with. The other triangle you should know is this equilateral, sorry, isosceles triangle. 1, 1, what's the remaining length?
1 square plus 1 square.
And then you take the
square root.
Okay. What's the angle here? 45. Here is 90. Right angled isosceles triangle. Always 45, 45. Right? Isosceles triangle base angles are equal.
Yeah.
Okay, then from here you're supposed to know the exact values. Like say theta is 30 degrees, 45 degrees, 60 degrees, i.e. pi by 6 radians, pi by 4 radians, and pi by 3 radians. How I remember it is like this. Pi is 180 degrees. If I divide by 6, I get 3. If I divide by 3, I get 6. T. 3t, 30. And 4, I get 45 degrees. Can? Can, okay, then that's 3 angles you should memorize. Then after that, you must know what is the sine, cosine, and tangent of each of them. I teach you a trick. This one for lazy people. I am lazy. Okay, how do you find sine 30? It's pretty okay. I memorized this already. It's over 2 over 2 over 2. Square root, square root, square root. Copy paste, copy paste, copy paste. 1, 2, 3, 3, 2, 1. Did you know that?
No.
Now you know. If you don't remember how, let's say for example, I test you. Okay, cosine inverse of square root 2 over 2. I want exact answer. You should give me 45 degrees straight away because it's from this table. Cosine inverse of square root 2 over 2. If you don't know, then how? Don't worry. The calculator, if you get if you use radian mode, you're gonna have trouble because cosine inverse of root 2 over 2 pi by 4 is what? It's a bunch of nonsense on the calculator. String of numbers 0.785398. You won't know what is this, right? So the trick here is to go into degree mode first. temporarily. Then you cosine inverse.
Oh.
You'll get an exact 45 degrees.
Oh.
Then after that, you convert. I hope you remember how to convert between degrees and radians. Please tell me you do.
Is it times pi over 180?
Yes, correct. Okay. There's only, yeah. So degree to radians times pi over 180. Radians to degree divided by times 180 over pi, other direction. Just like conversion rate, huh? SGD to Malaysian ringgit times 3, this one times 1/3.
Yeah.
Okay. So yeah, so you do that, then you can convert it and you'll get pi by 4 if you really cannot remember. And how about if I tell you, I ask you to find for me sine of 60 degrees, the exact value. Is √3/2, right? If you type in the calculator, depending on your model, it may or may not display the correct the exact form. Oh, sorry. Please make sure you're in degree mode.
Oh, okay.
Yes, do you get 0.86600 whatever 025?
Yeah, I get the 0.866.
Oh, so yours is the older version of the calculator.
Yeah.
Don't worry, you can still use it. Don't waste money buying a new one. Here is how you can use the calculator to help you to recover √3/2. So first thing you must memorize is it will always be square root question mark over 2. This format. The goal is to find out what is the question mark. You can use a bit of algebra. So you see, here's the trick. Sine 60 degrees, you can equate it to square root question mark over 2. What if I square both sides? I'll get sine 60 degrees square equals to what do you get after you square this?
The question mark.
Okay, maybe I don't put question mark, I put x.
Oh.
The x over 4, exactly. Then sine 60 degrees square. Type this in a calculator. I think you should get an exact answer. Sine 60 is 0.866, whatever. It's not exact, but after you square it, what happens? What does it give you? Oh, 3/4 equals to x over 4. So what is x?
X is 3?
Yeah, exactly. Yes. Oh, so now you know x is 3. Then you can replace the question mark with 3.
Oh.
This is the procedure to do. So basically, you sine 60, you get a string of you get a spaghetti of numbers. You square it, and then after that, you manually square root it.
Oh.
Okay. So what I do is, if I forget, I will type sine 60 degrees bracket square. I get 3/4. Okay. Then I need the exact value of sine 60 degrees. Square root. Square root 3 over square root 4. Square root 4 is 2. Square root 3/2. That's only if you really cannot memorize. For me, I already memorized this. I don't need to do this. Sine 60 degrees is square root 3/2. Okay, 1, 2, 3, 3, 2, 1. Then tangent, please remember, is sine over cosine. So top over bottom, 1 square root 1 over square root 3. That's just 1/3. Oh, that's just 1/3.
Oh.
Then this one, same number, divide by same number, you just get a 1. Then top divided by bottom is √3/2 divided by √1/2. The 2 cancel off, you're left with √1, which is just square root 3. Can? Sorry, this one is square root 3. 1 over square root 3. Can, that's the exact values from Amax. You should already know this. Coming back to the question. Okay. Here, step 2, you label the angle here, and then now you need to find, then you can, step 3 is use tangent inverse. Make sure all positive. And then number 4, how do I say this? Use the correct formula for the correct quadrant. For the APT apt quadrant, appropriate. Okay, so in this case, you put a negative because you're turning clockwise.
Yeah.
Like, and I showed you already, quadrant 1, 2, 3, 4. You can go and look at the video again. The correct formula for the correct quadrant. Okay, that is the argument z. Not done yet. That's argument z. That's a negative pi by 3. Then finally, 10 multiplied by negative pi by 3. So negative 10 pi over 3. 可以吗? Does this make sense? Okay. Good. Let me just double check first. Okay, something wrong. Not done yet. Sorry. Remember about the principal argument thing?
Yeah.
Or principal angle, principal argument, same thing. It means that negative pi less than theta less than pi. Here, negative 10 over 3 pi is approximately negative 3.3 pi, which is far below, way less than the negative pi. So what do we have to do?
Must add like pi.
No. 2 pi, multiples of 2 pi. 2 pi, 4 pi, 6 pi, 8 pi. Okay?
Okay.
Multiples of 2 pi. So let's add on 1 copy. Is it enough? You get negative 1.3, not enough. Then you times 2 plus 4 pi. What do we get? Don't use the approximated version. Use the exact version. So negative 10 over 3 plus 4 pi. Maybe I show you the working.
Like
Negative
0.7 pi.
Plus 4 pi. Let me see. I also need a calculator for this already. 4 minus 10 over 3. No. What? 0.7? Bit funny. Don't type the pi in, just type the fraction plus 4. So how many pi?
2/3.
2/3 pi. So this is equivalent to 2/3 pi. Can? Understand? The principal argument, principal angle idea?
Yes.
Add or subtract multiples of 2 pi. Here is the multiple of 2 pi, 2 copies of 2 pi. You can sometimes be 3, can sometimes be 4. So this is the answer they are looking for. You have to do this. Your angle must always be inside the principal argument range, principal range. Okay?
Okay.
Question 14, I'll leave it for another day. That's all for today. Try all of the questions in this worksheet.
Okay. Question 14 also.
Yes.
Okay.
Or maybe don't spend too much time on that one. It's a bit difficult.
Okay.
Okay, that's all.
So,
Oh, do you want more practice questions? I have more. I mean,
can send, but I'm not sure if I can finish.
yeah, or should we move on to a new topic? Complex numbers. Okay, we'll see. I'll just do that worksheet first. That's the most important.
Okay, can.
All right, that's all for today.
Thank you. Bye-bye.
And thank you. Bye-bye.